What separates junior developers from senior developers? It's not just writing code. It's designing systems that scale and stay simple for users while staying rock solid under the hood. Most tutorials stop at screens and styles. You never see how real apps handle state, authentication, database complexity, or debug and monitor errors in production. That leaves you stuck shipping half-baked clones. I'm Adrian, and in this video, we'll build a 6-screen food delivery app in React Native that's both pretty and functionally solid. You'll learn to think like a product engineer and not a copy-paste developer. You'll implement every core feature mobile apps need: email and password authentication, tab and stack navigation for fluid routing, home screen with real-time food offers, search screen with name and category filters, user profile screen, and a production-style cart and add-on logic, error monitoring, and crash tracking too. We'll use clean architecture, reusable hooks, and polished UX. Plus, I've dropped a video kit link down below with a free code repo, free Figma design, and a free Ultimate React Native roadmap, so you always know what to build next and so that you can use it if you get stuck. I'll teach you how to spin up your React Native apps fast with Expo, style them with NativeWind, manage state with Zustand, power your backend with Appwrite, and ship bug-free code with Sentry. This is the go-to stack for building professional React Native apps. So if you're done with half-baked clones and ready to think like a senior engineer, from database design to bulletproof error handling, this is the video you've been waiting for. So grab a coffee, hit subscribe, and let's architect something you'll brag about. Before we start setting up our application, we first need to set up and initialize our project using Expo. Expo is an ecosystem of tools that helps you develop, review, and deploy native applications with React that run on Android, iOS, and on the web. So to get started, let's head over to the docs. And right at the top, you'll see a quick start: npx create-expo-app add latest. So let's copy it or follow along and type it with me by heading over to your IDE and creating a new empty folder, which you can call however you'd like. I called it fast food. Throughout this course, you'll see me use WebStorm, a truly powerful JavaScript and TypeScript IDE. For the longest time, WebStorm was a paid editor, which means that mostly companies and enterprises used it. But as of recently, it became completely free for non-commercial use. And for that reason, I would highly recommend you to check it out and download it. I'll leave the link down in the description. So whenever there's some interesting tooltips or visual hints happening right here within the editor, if you don't have it on yours, it's most likely coming from WebStorm. Oh, and on top of it, I'll also show you how to use Junie, JetBrains' smart coding agent. It'll significantly speed up your coding process where you can just tell it what to do and it'll apply the changes across hundreds of files within your application, not just changing a couple of lines within a single file. So more on that soon. So once you've set it up, you can open up a new terminal window and we can set up Expo. I'll do it by pasting the command I just copied over from Expo, npx create-expo-app add latest, and I'll also add the / at the end so it creates it in this current folder called fast food that I created before. And just press enter. It'll ask you whether you want to install the Expo installer, so I'll say yes, please do. And then it'll extract all the files and run npm install for you to automatically install all the dependencies needed for you to run your application. While it's getting installed, let's create an account on Appwrite, as we'll need it later on while building our app. I've put a special link down in the description that'll let you follow along and see exactly what I'm seeing in this video. And even though Appwrite is completely free, you'll even get some additional free credits if you ever decide to take your app public. Just create an account, as we'll use Appwrite to authenticate our users, store menu items, and manage our images. We'll also use Sentry, an application monitoring software considered not bad by 4 million developers. And it's my favorite way of shipping bug-free production code. I also use it on jsmastery.com. Sentry is also free, but if you think you'll need 50,000 more errors, you can get them with my special link in the description. Then sign up with Google or GitHub, and you're good to go. Oh, and Sentry recently announced Seer, their AI agent that solves the bugs for you, so I'll show you how to use it too. Now, the first command we have to run is npx expo start. Now, npx stands for download if necessary, and then execute, the expo start command. This command will start the Metro bundler, the JavaScript bundler that ships with expo. You'll see a couple of things appear right here. First, we have a large QR code, and then we have shortcuts for various actions, such as opening on Android, iOS, or web, opening the debugger, reloading the app, and doing all sorts of things. But the beauty of Expo is that you don't need to rely on heavy tools like Android Studio or Xcode. Instead, we can opt for the easiest method to develop with React Native, which involves using the Expo Go app on your phone. And it doesn't matter whether you're using an Android or iOS. Expo Go is a mobile app that lets you quickly develop, test, and prototype applications on both Android and iOS, built with JavaScript and React Native. So you just have to head over to your App Store on your device, whether it's the Google Play Store or the Apple's App Store, and then search for Expo Go and just install it. Once you install it, just open it up, and you'll have to create an account. Once you do that, you can see that it says that we can run npx expo start, which we have already done. And then if you're on Android, you will be able to scan your code directly from the app. And on iOS, you can just open your camera app and then scan over the QR code. And there you go. If everything worked out well, your app should now be running on your phone. It is possible that you have to enable some additional settings on your device. On the iPhone, for example, I know that you have to head over to the settings, head over to the Expo Go application, and then allow it access to the local network if it hasn't asked you that already. Also, you can search for VPN and head over to the setting that you can see and then disable it. Sometimes if it's turned on, it has trouble connecting with the application that we're running. With all of that done, you should have your application up and running on your phone. Now, before we start adding all of these amazing features, let's open up our File Explorer and let me teach you what all of these files that got installed for us by Expo actually do. Let's start near the bottom where we have our tsconfig.json. This file contains the rules that TypeScript will use to enforce type safety throughout the project. Then there's the package.json, which contains all of the project's dependencies, scripts, and metadata. There's also the app.json, which contains the configuration options for the project and is called the app config. These options change the behavior of your project while developing, building, submitting, or updating your app. And a lot of stuff is happening in this file. So let's go through it together. The expo object is the root object containing all of the app's configuration. It contains the app's name, which is very important as that is the name that'll appear on the home screen or the app list when you actually load it within your phone. Then there's the slug, which is a unique identifier for the project used by Expo. It's used for defining the URL of your project if you're running this app on the web. Then there's the version of your application, the default screen orientation mode, which I will leave as portrait. Then there's the path to the icon, a scheme to enable deep linking. This will be very important later on, so just change it to the same thing that I have right here so you can follow along nicely. It is just fast food. Then we have the user interface style, which determines the UI mode, either automatic, light, or dark. And then there's this cool new Arch thing enabled, which enables the new architecture of React Native for better performance. It actually includes a lot of stuff that makes your app run faster. Moving ahead, we have the iOS and Android specific settings. For example, you can decide whether your app supports tablet devices or not. And then here you can choose the icons for your Android devices. There are also settings for the web. Now, coming out of the app.json, we have a few more files like the ESLint config, which just makes sure that our code is clean. a gitignore file, which ignores environment variables and makes sure that we don't push them over to production accidentally. There's also the scripts folder, which has a single script for resetting the project to bare minimum code. And then there's some boilerplate code like hooks, constants, components, assets, app, and more. As you can see within the app, there's also a tabs folder in parentheses, which is a group within which we have more files. If you head over into the tabs index.tsx and open that file, now if we change this text right here from welcome to rn, as in React Native, the change will happen instantly on your device. There's a lot of code, but we don't have to dive into this as I'll teach you how to do everything from scratch. So let's run this single script that was provided to us by Expo called reset project. This will reset the app to the bare minimum status. So just open up your terminal, press Ctrl+C to stop it from running, and then run npm run reset project. Just like that. It'll ask you whether you want to delete all the files, and I'll simply say, yes, delete them. Perfect. Project reset complete. Next, run npx expo start to start it, then edit the app index.tsx, and then delete the app example directory. Let's do just that. npx expo start. It'll open it up right here, and you can press R to reload the app on your phone. It'll ask you whether you want to give it your permissions. I'll say yes. And now we can delete the app example as we no longer need it. And then if you head over to app index.tsx, you can now change this over to welcome to React Native. And there you have it. In a matter of seconds, the text got changed. This leaves us with a bare minimum app so that we can extend it and turn it into your mobile app. Now that we've set up our app, we have to figure out how to style it. And for styling, I'll use NativeWind. Probably the best way to style your React Native apps nowadays. It's a utility-first workflow you love from Tailwind CSS directly within your React Native applications with the same intuitive classes. So it'll allow you to style your iOS and Android apps with light and dark mode support, CSS animations, variables, and more. As I said, the best way to style your React Native apps nowadays. So head over to NativeWind, get started, and under installation, you can see that NativeWind works with both Expo and framework class React Native projects, but Expo provides a more streamlined experience. So nowadays, there's really no reason not to use Expo anymore. So if you choose Expo, you'll be able to see the configuration with Expo. So let's go ahead and follow a couple of these steps. First, let's install NativeWind and its peer dependencies such as Tailwind CSS, React Native Reanimated, and React Native Safe Area Context. You can do that by copying this command and then heading over to your terminal. I'll actually open up a new terminal window so we can leave our current app running. And I'll call it terminal. This one I'll call app. Within terminal, I'll paste the command and just press enter. This will install all of the necessary dependencies and dev dependencies. And once that is done, we have to set up Tailwind CSS. So run npx Tailwind CSS init to create a new Tailwind config.js. I'll do it right here. And a new config should have been created within seconds. Here it is. Then we have to modify it to include all the paths to all the files that contain NativeWind classes. So just copy it and override this one. Perfect. After that, create a CSS file and add the Tailwind CSS directives. It should be right within the app where you can create a new file called globals.css. And WebStorm is asking me whether I want to automatically add it to Git. Yeah, I'll say sure, go ahead and do it. And here we can paste the Tailwind CSS utilities that will allow us to actually use it within the code. After that, we have to add the Babel presets. So just copy this file and put it over to Babel config.js, which we have to create in the root of the application. So that's going to be a new file called babel.config.js. and just paste over what you copied from NativeWind. After that, we need to create one more file or modify the existing one called metro-config.js by copying this and then creating it. That's going to be metro.config.js and paste over what you just copied. Finally, we need to import our CSS file within the app.js. Or even better, you can do it within your app layout. That way, it'll automatically be included within all of the other screens. So I'll just say import globals.css. And finally, we have to modify our app JSON to switch the bundler to use the Metro bundler. You can do that if you head over to your app.json and then search over for the bundler. Currently, it's already set to Metro, so we're good. And finally, for the optional TypeScript setup, we can add this reference to nativewind-env.d.ts. So just copy it and create a new file right in the root of your application, which you need to call nativewind-env.d.ts. And you can paste this reference right here, which will add the NativeWind types. Perfect. And then you're ready to try it out by copying this modify app.tsx and pasting it directly within your index.tsx. So just override everything that's here and rename it back to index, export default function index. And finally, we can try it out by copying this JSX or TSX in this case. I'll copy just the view and then pasting it over within your index.tsx instead of the existing view. If you do that, and if everything is working properly, you should be able to see that this text should be in a blue color with a white background. But I don't think this is a blue text, right? And it's definitely not extra large. So we just ran into something that will happen quite often. Even though Expo made developing React Native applications so much better, it's still not 100% as convenient as developing web apps. Hot reloading is so much better on web, whereas on native, sometimes you still have to manually reload your application. Oh, but in this case, it looks like we have an issue where we're trying to import the globals.css. That is right here within the layout. Let's see what is it complaining about specifically. The globals variable should exist right here within the app, but it looks like it's not recognizing it. So yeah, let me just stop it from running by pressing Ctrl+C and then rerun the application by running npx expose start. When you do that, you can just either rescan it or just press the letter R on your keyboard, which will trigger the redeployment, which in case you made changes, will build the new JavaScript bundle once again. Now you can see that we don't have any issues, but still, it looks like our NativeWind styles are not getting applied. One check that we can make is within the Tailwind config, where we're currently pointing specifically to the app.tsx and to the components folder. But I'm not applying those files within the app component. It is within the index, and I'm not applying it within the components folder either. So instead, we can add a more complete path that'll tell NativeWind to apply the styles across every file within the app folder that ends with tsx or JSX. So to do that, I'll copy the part with the components and I'll override this one right here. I'll say /app /* dot, and then these file extensions. This will make sure that the styles are getting applied within the index.tsx of the app folder. So now you can try reloading the application to see whether that does something. But if even that is not working, stop it from running and then run npx expose start -- clear. This will ensure that the metro configuration we set up is in the build process. So now you can see what I meant when I said that native development is still not as convenient as web development, but we're getting there with the help of Expo. So now run R to reload the application one more time. And oh, it looks like it's still not there. So let me do one final check. Within this metro config, where we have this global.css file, we have to make sure that it's actually pointing to the right file, and that is within the app folder. So right here under input, you have to change it to /app /global.css, or if you called it globals like I did, just make sure that it points to the same file because this CSS file contains the Tailwind utilities. So now if you start it once again with mpx expo start clear, you can see that it's rebuilding it. And with R, you can reload, and this time it actually works. Welcome to NativeWind. So yeah, there are some inconveniences, but I also made some mistakes while setting it up along the way. It is very important for you to be able to follow the docs properly. As you saw, just copy and pasting everything was not ideal. Sometimes you have to actually do some thinking, and notice that we weren't trying to use it within the app.tsx. We wanted to use it somewhere else. In a similar way, you have to notice that here it's pointing to global.css, but maybe you called it globals. Maybe you put it within another folder. You just have to keep that in mind and switch as you go. So with that in mind, NativeWind is now working, and you can now change all the colors and use all of the Tailwind utilities very, very easily. With WebStorm, I'm also getting automatic Tailwind CSS IntelliSense, so I can see which specific class name applies which specific properties. So for example, font bold is applying a font weight of 700, and text XL is applying a larger font size, as well as a bit of a larger line height to accommodate it. Now, the beauty of Tailwind CSS and NativeWind is the ability to customize it or extend the theme. For this app, we need to define a specific set of colors that we want to use. And those colors we can get directly from the design. So if you haven't yet downloaded the design, it'll be right within the video kit linked in the description. Right here. Once you click it, you'll get a full free design for this amazing food delivery app, starting with everything from Auth Screens to success screens, as well as the homepage, search, and more. And from here, we want to extract some of the colors. For example, let's say that we want to extract these 4 colors. We have the red, the yellow, the green, and the orange. So you can select a specific element and then copy the color right here. Then if you head back under Theme Extend, you can now specify a variant of a color you're trying to use, for example, red. And then under red, you can say that it can be maybe red 100, and then you can paste this string that you just copied, so that in the future, when you want to try to use it, you can just say text red 100, and this will apply the color we just copied, as long as you actually put it within the colors. So don't forget to put the colors object right here, and then place this red right within it. That's how you properly override it. And if you want complete course on Tailwind CSS, if it exists or if there's a waitlist for it, I'll link it somewhere within the video kit down below. Let's also try to do green. I'll copy this, which is our version of the green color, and add it under colors, green. Let me do 100 and just paste it right here. So now if you try to change it, instead of getting some boring green, you'll get our green variant. Maybe it's better if we set it as the background color. So I'll say BG green 100, and there you have it. Of course, this doesn't look the best. So instead, we want to create an entire color palette, starting with everything from this primary color, which will be this orange one, to the accent colors, maybe like this one right here. You want to get access to all of these colors so it's easier to use them later on. Sometimes you might have to double click a couple of times to get to the actual color. Just so you don't have to do a lot of clicking, in the video kit down below, I'll prepare the complete Tailwind config.js so you can just copy it and paste it right here. It'll include some fonts as well as some colors that we're going to use. So while we're here, let's also set up these fonts because they're not just available automatically for you. It's a special font that I decided to use for this fast food application. So we have to get access to it. Thankfully, I already prepped it for you. You can guess where it is, right here under Assets. So just download it, head over into your current application, delete the existing Assets folder, and then drag and drop this new Assets folder right in. It'll contain all of the quicksand fonts, the icons that we want to use, such as the bag, check, clock, dollar, and so much more, as well as some additional images, such as the avatars, avocados, bacons, and additional toppings that we can add to our application, alongside some success icons. Alongside the assets, to be able to use these images very quickly, we also need to create a new constants folder. So right here in the root of our application, create a new folder and call it constants. And within constants, create a new file and call it index.ts. In the video kit down below, you can find the final index.ts and just copy and paste it right here. Once you do that, you'll notice that this file is nothing more than a large list of imports for all of the icons and images that we have, as well as an array of the categories and the offers that are actually using those images, as well as the sides such as fries, onion rings, and so much more, where we actually attach a name and a price to a specific image. That's it. This just allows us to use it more easily later on within our application. But it looks like our IDE is not okay with us importing those assets. Even though if I right-click on it, it actually opens up, but it's complaining that it doesn't know what that is. So to fix it, you have to create one new file right within the root of your application and call it images.d.ts. And within it, you can copy and paste the final images.d.ts from the video kit down below. It basically says, hey, there are images, JPEGs, GIFs, and SVGs, and you'll be able to import them if they're being exported somewhere else. So once you do that and head back over to index.ts, you'll see that no longer it complains and you can actually get to them. Okay, but I believe we were not on the constants. We were actually talking about the fonts that are within the assets, right? So how can we put those fonts to use? Well, head over into the app and then layout.tsx. Whenever there's something that you want to reuse across multiple screens within your application, well, that means that you most likely want to put it within the layout.tsx. Oh, and I can't keep looking at this off green color that we have within our index. So I'll just change this over to text blue 500, and I'll change the background back to white. There we go. That's a bit better. And I'll say, welcome to my React Native application. That's much better. So now let's head back over into the layout. And let me actually import something called use fonts at the top. Within square brackets, it's an expo hook that loads custom fonts asynchronously. So it's coming from expo font. Then I'll also get access to the use effect hook coming from React. And directly within a root layout, I will say const, open up a square destructuring syntax, and call the use fonts hook. To it, you want to pass an object that'll list all the fonts alongside their names, such as quick, sand, bold. And then you have to require the path pointing to that font, such as /assets/fonts/quicksandbold.ttf. And I will duplicate this 4 more times. For the second one, instead of calling it bold, I'll call it medium. Then after medium, we can have a regular. After regular, we'll have a semi-bold. And the last variant should be light. There we go. So now we're importing all of those fonts, and it looks like it can't find them. Instead, quicksand, I believe, within the assets fonts, is spelled with a lowercase s. So I have to fix this a couple of times for a lowercase s. Once you do that, you might need to reload. So open the terminal and press the letter R. Oh, and I just have to fix one small typo. It is quicksand. And reload. Now we get access to the variable called fonts loaded, as well as the errors if they don't load. And then we can use a new use effect hook, which is a hook that gets triggered whenever you run your application or whenever the dependencies change. So here we can say to rerun this function whenever the fonts loaded changes or when the errors change. And then we can say if there is an error, simply throw that error. Let us know what went wrong. But if the fonts loaded, well then we can render a new splash screen. This splash screen is coming directly from the Expo router, and this will let you manually hide the splash screen once the resources are loaded in. So I'll say splash screen dot hide async. You know how on mobile devices, when you open up an app, there's that little splash screen that shows up while it's loading? Well, once we load the fonts, we can hide it. Finally, you see this ugly index header present at the top? Well, we can very easily remove it through the screen options prop, where I'll say header shown will simply be set to false. If you do it like this, now we just have a very blank screen with one single piece of text, and we are ready to test this font out by heading over to this app.indextsx. Before I test out the font, I'll make the text a bit bigger, like text-5XL. There we go. Welcome to my React Native app. I'll also center it by giving it a text-center. And now I'll change the font by saying font-quicksand-bold and press save. See how now it applied a completely different font, which is much more playful. And if we change it to this text-primary, it just might make you want to order some food. It works very well with a food ordering application. So with that in mind, we have now not only set up the styling for our application, but also initialized our own custom styles within the Tailwind config.js, as well as imported some of the fonts, icons, and images, and made it easier to use those fonts, icons, and images within our application by exporting them all from a single, simple constants file. Pretty cool, right? With this done, in the next lesson, we can immediately dive right into setting up our home screen. Let's get started with developing our homepage, which will look something like this. We'll mention our location, show the user's cart, and then show some of the categories of products that they can order. And then we'll have a bottom navigation. To start implementing the home screen, or any screen for that matter in React Native, you want to wrap it not with a regular view, but rather with a safe area view. This is a component which you can import from React Native safe area context, not directly from React Native. Even though React Native also has a component called safe area view, this one is much more powerful and works better on both Android and iOS devices. Safe area view ensures that the UI within it doesn't get cut off by notches or curved edges on any devices. So you can be sure that whatever you put in it will actually be shown to the user. Then after that, to efficiently render large lists by recycling different views, we use something known as a flat list. It is the recommended way of rendering lists in React Native. So I'll create a new flat list and import it from React Native. And you can see how WebStorm automatically autofills different props that are required for flat list to work. So it's the data, and then it's the render item. To the data, you need to provide an array or an array-like list of items to render. For now, I'll just pass an empty array. And then to the render item, you need to provide a callback function where you can take the item from that data and then render it. So this typically includes a callback function within which you destructure the item that you passed within the data, and then you automatically return something, like let's say an empty div for now. Later on, we'll make this flat list return actual data. You can think of the flat list as very similar to a .map function in React. For example, data.map, and then you show different items. This is the equivalent of doing that in React Native. But using the flat list is preferable when list is going to be dynamic or long, because React Native behind the scenes applies some additional performance optimizations. Okay, so within this data, instead of providing an empty array, we can provide a list of offers that we have, which we can import from add/constants. This will simply be different categories, such as the burgers, pizzas, or burritos. And then we can map over those items. I'll do it by getting both the item and the index of the item we're mapping over. And then for each one of these, we can open up a function within which we can return a view. Now, a view in React Native is very similar to a div in web applications. It's basically the same. It's a mobile app version of a div. Within this view, we can try to render some data. But before we do that, we want to make sure that whatever is within each one of these list items is interactive, is clickable, or in this case, should I say pressable, because we're not clicking on it with our mouse, we're actually pressing on it with our finger. Thankfully, there is a component called pressable coming from React Native, which allows you to put different components within it, and whatever is within it, you'll be able to click on it. Let's also give it a class name equal to, and now we can start adding all of the different class names. For example, we can give it a background of, let's say, Amber 600, just so we can visualize it more easily. And then within it, I'll render a piece of text. You can think of this as a p tag in regular web applications. Within it, we'll try to render the item.title. This will be the burger bash, summer combo, or a pizza party. So if you save it now and reload by opening the terminal and pressing the letter R, you'll see that now we have 4 different list items right here at the top. But to style it a bit better, we can continue adding some additional class names to this, such as maybe we can give it a margin Y of 3 to divide the elements one from another, maybe an H of 48 to give them so much more height, or rounded-XL to round up the corners a bit. There's going to be many of these class names that we want to add, and not necessarily always do we want to clutter our view and do it directly here. Sure, Tailwind and NativeWind are amazing because they allow us to add all of those class names immediately, but sometimes we want to extract them within a globals.css file so we can more easily use them and reuse them throughout our code. So for that reason, in the video kit down below, you can find the complete globals.css file, which you can copy and just paste right here. You'll see that this contains some of the utility classes that are going to make the styling of our applications easier. For example, whenever you want to render an H1 bold heading, you can automatically use this class and it'll apply a text3XL as well as the font that we're using. Similarly here, for one of these cards, we can apply a full width, H of 48, margin Y3, rounded XL, and so on. And this is going to be one of the last things that I'm going to provide you with. Everything else that's coming up will code together by hand. I know that I gave you a lot of assets and a lot of things to work with at the start, but from here on, you'll be doing everything on your own, with my help, of course. So now, if you head back over here, instead of providing all of these things manually, we can now just give it an offer card class name. And if you reload your application, you'll be able to see that we have 4 of these different things. But hey, where are the colors? Well, in this case, if we want to provide a different color for each one, we have to do it using the regular style property. So I'll just say style and choose a background color and make it equal to the item.color. Where's this item color coming from? Well, it's coming here from the offers. I already picked them from the design and put a couple of these colors here so that each one gets its own color. Now, instead of simply rendering a piece of text within this pressable property, instead, I'll open a new dynamic block and I'll render a callback function with an immediate return. And then in here, we can render what will be pressable. And we also have access to this pressed function so that we can do some additional functionalities once the user actually presses it. Let's make sure to properly close it. And within it, I'll render a good old React fragment, and then I'll render a view. Make sure to import this fragment from React just to be able to render it. There we go. And now we have 4 different colors. Within this first view, we want to give it a class name equal to hfull and w1/2, which is half the width of the card. And now that allows us to render our image. So I'll render the image in the same way I would do it within the browser, but this image component will be coming from React Native. And then you can give it some props like the source, which will be equal to item.image. It'll have a class name of size-full, as well as resize mode equal to contain. And we can close it right here. So now you can see 4 different images appear right here. Now we can render the text. So I'll say view that'll have a class name equal to offer dash card underscore underscore info. So we're using a bit of the CSS BEM methodology here to indicate that this is the info part of the offer card. And then within it, I'll render a piece of text that will render the item.title. So if you save it and reload, it looks like we still can't seem to see the text. That has to do a bit with our layout. See, we're using an alternating layout right here for some visual interest. We start with a large text on the left and then image on the right. But then on every odd card, we change it. So on the second card, we have burgers on the right, but the image on the left. Then we have the text on the left and then the image on the left. So we have to figure out a way to change the layout based on the number of the card. We can do that right here at the top of the render item function by checking whether the card is even. We can do that using the modulo operator by checking whether the index is equally divisible by 2 with no remainder. Then we can use this isEven variable to render some different class names for this pressable component. To render dynamic class names, we can install an additional package called CLSX. So open up your second terminal and run npm install CLSX. Then we can just use it right here by not only rendering this offer card, but rather passing it into this cn function, which we have to import from CLSX. There we go. And now we can always render the offer card class name, but then dynamically, if it is even, I will give it a flex row reverse. And if it is not even, then I will give it a flex row. This will create an alternating layout. So now we can see that at the start, we have the summer combo on the left, burger bash on the right, pizza party on the left, and burrito delight on the right. And just so it's a bit easier to see, I'll put this class name and the style on the new line, so you know that they belong to the pressable component. Perfect. So now we are ready to style the text. I'll give this text a class name equal to h1 bold, text dash white, and leading dash tight, which I believe we coded before, but I removed it while I was fixing the text. There we go. That made it a bit bigger. And now just below this text, we can render an icon. So this will be an image that'll have a source equal to images coming from index.ts of constants dot arrow right. And if this didn't auto import it for you, right here from constants, just check whether you have this export const images right here that exports all of our icons and images. If you have it here, you're good. Let's also give it a class name equal to a size of 10, as well as a resize mode of contain, and a tint color of hash FFF, which is the white color. There we go. And now we have to make all of these breathe a bit better. So right here at the bottom of where we have this safe area view, so that is the full bottom of the screen, just before we close this flat list, let's actually give it another property of content container class name. And here we can give it a padding bottom of 28 to create some spacing, as well as a padding X of 5 to create some spacing on the sides. Let's also scroll all the way to the top to where we have the safe area view. And let's give it a class name equal to flex1, as well as bg white. If you do this, everything should still look good, but we still have to provide some space for this piece of text right here. So let's scroll down to this first image where we have a size full and a resize mode of contain. So let's scroll a bit down, and right here where we have this view with a offer card info class name, we can also wrap it with a CN for class names. We'll always render this offer card info, but if it is even, I will give it a padding left of 10, else I'll give it a padding right of 10 to create some additional space. There we go. So now it's looking much closer to the design. And also on Android devices, there's an additional property that you can pass to the pressable component, which is Android Ripple. And I'll give it a bit of a color of hash FFF FFF22. So this is for the opacity. So it'll actually make it look like you're pressing on it. Now we have to focus on rendering the top part, which is the header. So I will render it just above this flat list by rendering another view with a class name equal to flex between. So we can show the content on the left and the right. Flex row, W full for full width, margin Y of 5 to divide it from the top and bottom, and padding X of 5 to give it some padding on left and right. Within it, I will then render another view that'll have a class name equal to flex start. Within it, I'll render a text that'll say deliver to, and then we can give it a class name of small dash bold and text dash primary. There we go. So now it says deliver to right at the top, and then we can render an image below that text. This image will have a source of images, dot arrow down, and it'll have a class name equal to size of 3, as well as a resize mode equal to contain. There we go. So now we have this little caret at the top. And we actually want to put this caret alongside the text of where we're actually located. So I'll put it within a touchable opacity. This is the first time that we're using something known as a touchable opacity. But basically what it is just a button, okay? It has a fancy name for a button, which you import from React Native. Because if you think about it, in mobile apps, you're not pressing a button, you're actually touching something. So it's called a touchable opacity. And within it, I will render this image as well as a text. And this text will render the city where you're from, or just the country. In this case, I'll say Croatia, where I'm based. And now let's style it a bit by giving this text a class name equal to paragraph dash bold, text dash dark 100. And we can now style it all together by giving this touchable opacity a class name of flex dash center, flex dash row, so they fall one after another, and a gap X of 1, as well as a margin top of 0.5. And now it nicely says that you're actually delivering to the place where your users are from. And later on, of course, we can make this dynamic. On the other side though, for now, below this view, I will render a text that'll say cart. Here, we can display all of the items that you've ordered so far, or that you've added to your cart. Now, if you try to test your app, you'll notice that you can't scroll the whole screen. Rather, you're only able to scroll the flat list content. See how the header remains there, but flat list is scrollable. Why is that? Well, in web development, the browser actually adds scroll bars if the content exceeds the viewport. But in React Native, you're working in a native mobile environment, where the layout engine doesn't necessarily assume that you want to scroll. So you must explicitly wrap your content in a scrollable container like a scroll view or a flat list in this case, if you want to add horizontal or vertical scrolling behavior like we have here. So in case you want to make the whole thing scrollable, you can just wrap it in a scroll view, which you can import from React Native, and make sure to properly close it right at the bottom, right inside of the safe area view. If you do that, you can notice that now the whole thing is scrollable. But with this in mind, we have one tiny problem. And that is that if you open up your application terminal, you'll see that it says that virtualized lists should never be nested inside plain scroll views with the same orientation because it can break windowing and other functionality. Use another virtualized list backed container instead. This problem is happening because a flat list, which is a virtualized list, is designed to render only the visible items for performance, not the ones that cannot fit on the screen. Wrapping it in a scroll view, though, which tries to render everything at once, disables that optimization, causing poor performance, layout glitches, and broken scroll behavior. It is a pattern that you don't want to do in React Native. So please never ever wrap a flat list or any other virtualized list inside of a scroll view ever again, because that's a React Native rookie mistake number one. So if you want to avoid these mistakes in the future, you'll definitely want to check out our Pro React Native course. Now, it depends when you're watching this video, whether it's out yet or not. But even if it's not, somewhere here in the video kit down below, I'll link a waitlist for the course so that when it's actually out, you can be the first one to know and never again make this and many, many other common React mistakes ever again. Because in the course, we'll dive deep of how React Native works under the hood. So what should you do instead? Well, check this out. I'll remove this scroll view and its ending tag, and we can render this entire header as part of the flat list with the help of one special prop, which you'll notice as you dive deeper into React Native development is that React Native has a lot of these special props. So just copy this entire part and remove it, and then within the flat list itself, add a new list header component where you can declare a callback function with an immediate return and just paste what you just copied. Now it'll get re-added as part of the entire flat list, as you can see, but no longer do we have that issue with a virtualized list. These are just previous errors. The more you know, right? So we're just building different pieces of this flat list and adding them as Lego blocks. In this case, we don't even have to pass this padding X to the view because flat list adds it by default. So everything is nicely structured even without it. Perfect. So now if you test scrolling, you can see that everything should feel better as a one whole thing. Next, I'll create a separate component specifically for rendering the cart icon at the top, which will help maintain the consistency across the app. The idea is that when a user adds an item to their cart, the cart item should immediately update to show the new item count, and this change should be visible on all screens at once. By isolating this cart component, we can connect it to a global state. This way, any updates to the cart will automatically reflect in the icon whenever it is used. Additionally, having it as a standalone component just makes it more easy to reuse throughout the app. So let's create a new component within the components folder. Oh, look at it. This will actually be our first component. So we have to create a new components folder and create a new file within it called cart_button.tsx. And you should be able to quickly get it going by typing rnfe. If this isn't working, you might head over to the plugins and then search for React snippets. Very quickly, you should be able to find something that works. In this case, I'll go with these modern React snippets, install them, and once you reload, you should be able to type rnfe, which will create a new React Native functional export component very quickly. Then you can go ahead and import it over within our list header component. Instead of this text that says cart, now you can render a self-closing component called cart button and head over into it so we can implement it as a reusable component. For now, I will hard code the number of total items, for example, 10. And then we can automatically return a touchable opacity since it's a button with a class name equal to cartBTN. And instead of an on click, we can give it an on press, which we'll add the functionality for soon. Then I will render an image with a source equal to images coming from constants.bag with a class name of size5 and a resize mode set to contain. There we go. You can see a little cart at the top. And then only if the number of total items is greater than 0, then we want to automatically render a view, which will have a class name equal to cart badge. And within it, we can render a piece of text that will have a class name equal to small-bold and text-white, within which we can render the number of total items. There we go. So now we have a cart and it has a badge that says 10. And you can see since we put it within a touchable opacity, once you click it, it actually shows that it is a clickable component. Pretty cool, right? This will be a crucial component later on as it'll use a global state for the number of elements that we have within our cart. So with that in mind, we're now done with the UI of the homepage. So I want to focus on implementing the other pages, and thankfully there are many. For that, of course, we'll have to implement the bottom navigation, which is one of the crucial parts in any React Native app. Before moving to authentication and database setup, let's first set up the routes for the entire application. First, we'll need a couple of authentication routes for login and sign up. And if you check out the design for both, you'll notice that both of these screens have a similar UI right at the top. It's just the bottom that is a bit different. These screens are also different from the rest of the app screens, which have a bottom navigation right here. For that reason, we'll group all of these pages in one folder using Expo's shared layout feature. These shared routes are also often called groups, and these groups often share similar pieces of UI called a layout. So let's create our first group within the app folder, which I will call Auth. It's going to be a folder, and you have to put the name in parentheses to indicate it is a group. Within it, create a new file and call it _layout.tsx. Yes, you have to have that underscore for React Native to recognize that this is a special file, and specifically for Expo. Within it, you can quickly run rnf to quickly spin up a default layout component. And we can call it the auth layout. Within the same auth folder, we want to create two new files, one of which will be called a signin.tsx. And inside of it, you can run rnfe to quickly spin up a sign-in component. And then you can do the same thing for the second one and call it signup.tsx. Also spin it up with rnfe. Perfect. We'll see those routes in actions very soon, but for now, let's proceed with creating another shared layout that renders this common button tab navigation at the bottom for the rest of the screens. We can do that by creating a new route group, which I will call tabs. You can also call it root or home or something like that. And then I'll move this index.tsx within the tabs because that's going to become our new homepage. Within tabs, also make sure to create a new layout like we did before. I'll call it _layout.tsx. You can type rnf, which will quickly spin up a layout. But instead of just rendering an empty view with a text, instead, we want to render a self-closed component called slot, which you can import from Expo Router. What the slot component does is it renders the rest of the content as it is. Basically, it'll render the contents of the other pages that we have. So for now, leave it as it is, and let's create other pages. This one will be called cart.tsx, run rnfe, and let's duplicate the same thing over for our second component in the tabs folder, which will be called a profile.tsx. Also run rnfe, and then we'll have yet another one in the tabs, which I will call search.tsx, where I'll run rnfe and finalize our tabs folder. Now, if you reload your application, you'll be redirected back to the homepage. It feels like nothing has changed. But to test these three routes, head over to the tabs layout, which is a shared parent layout of all of these other screens. And inside of there, add a dummy check that'll redirect to the auth screen if the user is not authenticated. Later on, we'll replace this with a real auth check. But for now, we can say const is authenticated is equal to false. And then we can check if not is authenticated. We can simply return a React Native, an Expo redirect component from Expo Router, where we can point the user back to /sign in. Expo really is making React Native applications feel much more closer to the web. With this in mind, you should be redirected to a different screen. And if you pay close attention, it'll say auth layout at the top, but not sign in. That's happening because we have a special layout file within the auth route group. So inside of here, what we can do instead is wrap it with a safe area view, and then beneath the text, render a slot, the same component we rendered before. And now you can see that we have the auth layout, where maybe you can render the auth UI or the bottom navigation bar, but you also have the page itself rendered through the slot component. So now, just to make it interactive and to simulate a sign-in functionality, within this sign-in, we can render a button coming from React Native and give it a title of sign in. And on press, equal to a callback function, we use the router.push functionality to push over to sign up. Maybe if we want to switch over to the sign up page. And this router, we can simply import from expo router. But now you might be wondering, hey, didn't you say that in React Native we use touchable opacities instead of buttons? Yes, they're a preferred way of interacting with the UI. But for some very, very simple buttons, something like this one, even a regular button is fine. It is also made to work with React Native. So now if you click on it, it'll redirect you to sign up. Now we want to do the similar thing for the sign up page. So I'll copy these 2 lines of code and paste them over into sign up, where we can import router and then render a button to point us back to the sign in page. So I'll say sign in, and don't forget to import the button itself. So now we are in the sign up, we can go to sign in, and from sign in, looks like I misspelled it. This should say go to sign up. So now we can switch between those 2 pages, which means that we have effectively created navigation. And if you want to test out the other screens that you have created so far, such as the cart, profile, and more, you can follow the same thing that I've done so far and just add buttons that would redirect to those different pages. But you might switch off the is authenticated rule because it'll always bring you back to sign in. So just maybe turn it to true while you're testing and then bring it back. Later on, of course, we'll implement the entire bottom navigation so that we can actually move between all of these different screens. But for now, I'm fine with just having the base setup as well as the authentication, because from the next lesson onward, we're going to start diving into real functionalities. So it's important that we have our UI and routing for authentication done, and then we can actually connect it to our database and our authentication provider to create accounts on our application. And this is also a good point to maybe push our code to GitHub, because we've implemented a lot of changes, and we can basically say that we have created a base file and folder structure for the future of our application. So now is a better time than ever. Now, who am I kidding? It would have been better if we did it at the start of the project. You should always commit consistently and commit often from the start. But hey, better now than never, right? So let's create a new GitHub repository. You can call it anything you want, like JSM food ordering app, or you can just call it fast food app. And then you can make it either public or private. And then you can just create a repository with all of the default configurations. This will pull it up for you in a matter of seconds. The only thing you need to do here is just copy this one long line with git remote add origin, and then head back over to your terminal. I'll head over into my second one that is empty, and just follow my lead. Git init to initialize a new GitHub repo, git add dot to add all of the changes, git commit -m, and now we can type our commit message, something like set up the base file and folder structure for the rest of the app. Oh, and make sure to add git at the start. This will commit it. Then say git branch -m main, then git remote add origin. This is what you just copied. And then finally, git push -u origin main. In a matter of seconds, all your code will be live right here on GitHub. And it's always super useful to have your code online and to commit consistently. First of all, it's a good sign for potential employers to look at it and see that you're actually putting in the work. You can further tidy it up and give it a description, like a food ordering app. And while you're committing consistently, this is also just building your GitHub contribution graph, which is always good to see. Perfect. So immediately in the next lesson, we'll dive into setting up the core functionalities of our application. Let's get started with adding the primary logic and functionalities to our application. We'll do it using Appwrite. Appwrite is an open source, all-in-one development platform, and in this course, we'll use it for the backend infrastructure. This means that we'll be using their auth provider, databases, as well as storage. So if you haven't already created an account, you can click the link down in the description to follow along and see exactly what I'm seeing and create your account. You'll even get $50 in additional cloud credits when you upgrade or you decide to go for a pro plan, even though it'll not be needed at all to just be able to follow along with this course, as Appwrite is open source and completely free to get started with. Once you're in, you can very easily create a new project. You can give it a name starting with JSM, something like JSM food ordering, and you can choose one of the regions. That'll lead you to the onboarding. You've created your project and now you need to connect it to your platform. Alongside web at the top, immediately on the right, we have React Native. So select it. You can select either Android or iOS. Either way is fine. Enter the name of the app. I'll go with JSM food ordering. And then for the bundle ID, you can come up with any kind of an ID that follows this pattern, com.companyname.appname. So it's going to be, in this case, com.jsm, and then you can give it any name. Once again, I'll do food ordering, but make sure to remember it. And then I'll click Create Platform. If you're starting a new project, you can just use this command, but we already have a running project, so I won't be doing that. Instead, I'll head back over to our application, open up my terminal and make it a bit bigger. And we can run npx expo install React Native Appwrite, as well as React Native URL polyfill, and press enter, as this will install all the necessary dependencies. Then we can also copy our Appwrite credentials to our .env, which you can create right here at the root of your application by calling it .env and then pasting them right here. Expo public Appwrite project ID and expo public Appwrite endpoint. Now, back within our application, we can also create one more folder, which we can call lib. Lib, or library, will contain some functions or configurations that we can use throughout the entirety of our application. For example, here, I'll create a new file called appwrite.ts, and we'll use it as an Appwrite configuration. So here, we'll set it up, and it'll contain all of our credentials. So we can say export const appwrite config is equal to an object where we have an endpoint, and this will be equal to process.env dot, and then we have to see how we called it. It'll be expo public Appwrite endpoint. We can also choose the name of the platform that we have, and here it should be the same as the bundle ID. So I use the string of com.jsm.foodordering. If you forgot what you put for it, you can find it right here. Perfect. And then alongside the platform, we'll also have to have the project ID, which we can get from envs once again. That'll be process.env.expo public Appwrite project ID. Perfect. And with that in mind, our Appwrite setup is now complete, which means that in the next lesson, we can immediately dive right into setting up our auth. Okay, so let's talk auth. How would we go about implementing authentication within our application? Might be better if I sketch it out. So first things first, we start with the user entering their email and password. So I'll just say user enters data. Once they enter their email and password, we then want to call the Appwrite auth function. This function will then create a new auth user. And after we create a new auth user, we then want to call the Appwrite database. So I'll drag that here and just say call Appwrite DB. We then want to store this new user information in the user collection in the database, which we can then easily connect with some other collections to form relations. Like we have a single user that can then be associated with a couple of different orders, for example. So I have one order, 2, 3, and more, all associated with the same user. Or maybe one user can add multiple addresses to their account. So we have 1 and 2. We'll be able to easily create relations, and this is useful for any kind of an e-commerce or food ordering application. So for all of this to happen, we first have to create our database in Appwrite. So head over to your Appwrite console under Databases and create a new database, which we'll call App. Within the app database, we need to copy its ID and then store it within our Appwrite config. So back within our application, I'll head over to Appwrite TS, and right here below the platform, I'll add a database ID, which will be equal to this ID we just copied. After that, we want to go inside the database and create a new user collection. So create collection and call it user. Within it, we want to assign a couple of attributes. So head over to attributes and create the first one. It'll be a string that has a key of name with a size of 100, and we'll make it required. That's one. The second one will be email. So choose email, type in email as the key, and make it required as well. After that, we have the account ID. So create a new variable of a type string and call it account ID with a size of 2200 should be enough, and make it required as well. After that, we want our user to have their avatar photo as well. It'll be of a type URL, which you can call avatar, and make it required. Now you want to copy this user collection ID and put it within our config, just by saying user collection ID, and then paste what you just copied. If you want to, you can also put these IDs within your environment variables like I've done for these ones, but we can do that together once we collect all of them. For now, you want to head over to your auth layout. That is within the app auth layout, and we want to develop the auth screen header UI. It is this one right here that is being shared across both the sign in and the sign up, which is exactly why I'll put it within the layout. We can start by wrapping everything not within a safe area view, but within something called a keyboard avoiding view. Looks like this, keyboard avoiding view coming from React Native. And this component ensures that when a user is writing in any inputs, keyboard will appear below it automatically. It won't go above the input field. Also, when I was testing the app on Android, I noticed some weird behavior where we actually need to add some padding on iOS devices to push the content up, and we have to add the height on Android devices. So how do we do some changes depending on the operating system? Well, in this case, we can add a prop of behavior, which can be either padding or height, and we can make it dynamic and say platform, which you import from React Native .os. And this will give you access to the current operating system of your user's device. If it is iOS, I'll apply padding, else I'll apply a height. Finally, within this keyboard avoiding view, we can render a scroll view. This scroll view will have a class name equal to bg_white and age-full, and it'll also have a special prop of keyboard should persist taps, and it'll have a prop of handled. Now, what does this mean? Well, this prop ensures that tapping outside of the keyboard will dismiss the keyboard entirely, so that you can focus on clicking the submit button, for example. Then we can have an additional view right within that'll have a class name of wfull and relative. Now we want to apply different styles depending on the dimensions of the screen. So I'll say style is equal to height, and we'll get access to the height of the screen in a similar way how we got access to the operating system. You just say dimensions, which you import from React Native, and then .get, and here you can get the screen size. .height. Once you get it, you want to divide it by 2.25. I found this number to work the best. Later on, once we actually implement this screen, I'll show you what difference it'll make if we actually remove this height. Finally, within it, let's render an image background coming from React Native, not Expo image. It'll be self-closing with a source of images coming from constants .login graphic with a class name of size full and rounded -b -lg. B stands for bottom, with a resize mode equal to stretch. So now we have this nice pizza image right at the top. Then below this image background, I'll render yet another image, which will have a source equal to images.logo of our application with a class name of self-center, a size of 48, absolute positioning, minus bottom 16 to put it a bit below the image, as well as a z index of 10. So it appears over this image that we have. And don't forget to import image from React Native. Once you do that, you might need to reload just to make sure it's properly rendered. And here it is. Here you can put the logo of your fast food. And now, before we go on to developing the UI of the sign up and the sign in screens, let's create two reusable components we'll need on this screen. One is an input field and another is a button. So head over to components and create a new file, which will be called a custom input.tsx. Run rnfe, and there is our custom input. And the other one will be a custom button. So just create it in a same way. rnfe, and now we have two of these components. We can immediately try putting them on the actual layout for now, just so we can see them as we're developing them. So if I head over into Auth layout, right here within the scroll view, I will import the custom input as well as the custom button components, just so we can see them right here. And now it's our turn to actually develop them. So let me head over into the custom input first, and let me show you how we can make a reusable input component in React Native. I'll start by making this input accept some props. Things like a placeholder, which by default can say something like enter text. Then we can accept the value of the input, the onChangeText handler. And I want to put all of these in a new line just so it's easier to see. So we have the placeholder, the value, the onChangeText, and more. But I just wanted to properly indent it. Then we also want to get the label of an input and a secure text entry ability, by default set to false. If this was set to true, then we would not be able to see what we're typing, and this is perfect for, you can guess it, passwords. And finally, the keyboard type, which will be default. You can also change it to something like a number input if you want to. Okay, so where are we going to get these props from? Well, whenever you create a reusable component, you can pass some props to it wherever you're calling it. And here you can see that our custom input needs to accept some props. It can already infer that we have some props right here, but it is always a good idea to specify a type. For example, you can say this is of a type custom input props. And then you could define a custom interface. This is TypeScript related, custom input props, where you would specify the type of each one of these properties. Like a placeholder could be string, onChange is a function, label will also be a string, and so on. But just so we don't have to declare every single new type that we have here, you can create them right within a special file called type.d.ts, which you can create in the root of your application, like the images.d.ts that I provided before. So create it and call it type.d.ts. You can then find it right here within the video kit, copy it, and paste it here. This will include a couple of interfaces that we're going to use throughout the application, such as the custom input props interface that simply specifies which types of props do we want to pass. And then you can just say custom input props, and it'll automatically be able to infer it from that type declaration file. But now, getting back to where we actually pass those props, you pass them whenever you call this component. In this case, we're calling it right here within our layout. So let's for a second imagine that we're using it within our sign in or sign up pages. Maybe this can be, let's say, sign in. You'll need to pass a placeholder, something like enter your email. Then you can also pass a value. which we'll have to get from the form. So for now, I'll just make it an empty string. An onChange text, which will be a function. We also have to pass the label equal to email. And finally, a keyboard type, which in this case could be email address. Yep, there's a special type for that too. And now you can see that this component is getting what it deserves. It's no longer complaining because it knows which props does it need. And here I have a typo, secure text entry. Perfect. But now it's complaining that we're not actually using these props or parameters within the component. So let's put them to use. First things first, I want to wrap everything in a view that'll have a class name equal to wfull, so it takes the full width of the screen. Then we can have a label, so that's going to be just a text with a class name of label, and it'll dynamically render the label prop that we're passing into it. In this case, it'll say email. Then we can create a text input, and this is a component which we can import from React Native. It is a self-closing component, and it has a lot of interesting props that we can pass into it, such as the auto capitalize, which for now we can set to none because emails are not capitalized. Whereas maybe if you had a name field, you could auto capitalize it. Maybe autocorrect, which in this case we want to turn to false. A value, which will be equal to the value we're passing from props. Same thing for the onChange text. Oh, this was supposed to be autocorrect. Thank you for letting me know, TypeScript. And then we have secure text entry, keyboard type. All of these we're passing directly from props. We could also create the new useState hook, and we can call it isFocused. And this will track the focused or unfocused state of the input. Are we currently trying to type within it or not? Don't forget to import useState from React. Then, once we focus on this element, we can turn the setIsFocused state to true. But once we blur out of it, once we exit it, we can set it to false. We can also pass it a placeholder equal to placeholder coming from props, as well as a placeholder text color, which we can set to #888, which is a dark version. Finally, let's give it some class names. I'll use this CN functionality from CLSX to always give it a class name of input, but then only if it is focused. I'll also give it a border -primary, and else I'll give it a border gray 300. So that way we'll know whether it's focused. And check it out. You have an input on your screen, and it has a nice border if it's focused, but for now it looks like we just jump out of the screen and can't see it. Still, we have just implemented your custom input, which later on will not jump us out of the screen. So very quickly, let's do a similar thing for the button. We want this button to also accept some props, so let's get them right here. For example, an on press. We can also get a title, which by default can say something like, click me. We can pass an additional style, a text style, a left icon if it has it, and the loading state for that button at the start set to false. And we can attach a custom state to it, not custom input props, but custom button props, so we know what we have to pass to it. Now let's turn it from a view into a touchable opacity with a class name of CN. It'll always have a custom BTN, and we can also pass some additional styles to it. On press, we'll call the on press function that we pass through props. And there you have it, your custom button is already there. Still, let's style it up a bit more for different use cases. If it has a left icon, I'll also render that icon right here. And then we will render a view. This view will have a class name equal to flex center and flex-row. And within it, if we are currently loading, then I'll display a new component which we haven't used before, which is the activity indicator. Make sure to import it from React Native, give it a size of small and a color of white. But then if we're not loading, we want to show the actual text. So I'll render a text element right here, remove this one that we had before. And this one will have a class name of CN. We'll always give it text white 100, paragraph semi-bold, but then we're going to also attach some dynamic styles, such as these ones, which are coming directly from the props. Text style. There we go. And now this button is not saying anything, so let's make it render the title that we're passing into it through props, which by default is set to click me. And now that we have those two components, let's jump right into the sign in and let's put them to use. I'll first give this view a class name of gap of 10, BG of white, rounded dash LG, padding of 5, and margin top of 5 to structure these elements a bit more nicely. I'll also head within the layout and copy this custom input and custom button, remove it from here, and then add it over to this sign in, but I'll leave it at the bottom for now because we want to use it later on. Oh, but wait, when I paste them here, why aren't they actually showing up on the screen? Did I forget to add a slot to this scroll view? No, the slot is here, but it actually should have been within the scroll view, not outside of it. There we go. So now we can see the sign in and you can see everything. So now I'll head back to the sign in and let's actually implement it. Directly within this view, we no longer need this text or a button. We're going to start right off with a custom input that we have. This will be the email input. And then I want to duplicate it one more time below. This time it'll be for our password. So I'll say enter your password with a label of password. And I won't have the keyboard type, but I'll have the secure text entry. So whatever we're typing into the password actually gets hidden. We'll test this part very soon as we connect it with an actual form. And then just below it, we want to render a custom button. That'll have a title equal to sign in, and we're good. This looks like a proper, valid sign-in form. But whenever you have sign-in and sign-up pages, you also want to create another view so we can switch between the two. So I'll create another view that'll have a text with a class name of base-regular and text-gray-100. And this one will say something like, don't have an account, and then I'll create a link right below it that'll say, hey, sign up. This link will then have an href pointing to the sign up page with a class name of base-bold and text-primary. And of course, don't forget to import the link coming from Expo Router. There we go. Don't have an account, sign up. And now we can switch between the pages. We can also give this view a class name of flex, so they show one next to another, with justify center and a margin top of 5, flex row, and a gap of 2 in between the elements. So this looks just a bit better now. Perfect. But now let's make it functional. I'll create a new use state snippet right here at the top, and I'll call it is submitting. This will be used for the loading states. At the start, set to false. And don't forget to import the use state hook itself from React. I'll also create another use state, and this one I'll call form. Set form, which by default will be set to an object with an empty email and an empty password. Perfect. Then I'll also create a new submit function. Const submit is equal to an asynchronous function where we want to check if form.email doesn't exist or if form.password doesn't exist. That means that they haven't entered the data. So we just want to render some kind of an alert, which with React Native you can do easily just by saying alert.alert. You can choose the type of the alert. In this case, it'll be error, which is the title, and then the message of the alert. In this case, I'll say, please enter valid email address and password. Perfect. So later on, once we implement the sign up functionality, once you click the button, it'll give you an alert. Then, if these have been entered properly, we can start the submitting process. So set is submitting to true. And then we'll open up a try and catch block so we can properly authenticate our user. Here, we'll call the Appwrite sign in function. After that, we can maybe render another alert, dot alert, this time success, which will say user signed in successfully, and we'll just use the router.replace functionality to bring the user back to the home page. This router, of course, we have to import from Expo router. That is right here. After that, if something goes wrong, so catch, we catch the error of an any type. We'll also render another alert, rendering the error message. And finally, whether it succeeded or failed, we want to stop the submitting process. So I'll set is submitting to false. Perfect. Now we can actually put these states to use. Right here within custom inputs, for the first input, the value will be form.email. Here is where we're storing the value of that email. And on change text, we'll be calling the setForm state. Then you have to create a callback function because you're changing the state with the previous version of the state. So I'll say prev. And then you can create a new state object and automatically return it. You do that by wrapping an object in parentheses. We spread the previous state, and we change the email to this new text that we collected from this input. You can now also copy this value and on change and paste it for the second custom input, but this time it won't be the email, it'll be the password, and same thing here, we'll update the password. Finally, once we click the custom button, we want to pass to it the isLoading state, which will be equal to isSubmitting, as well as what should happen once we press the button. And what should happen is we should call the submit function. Perfect. So now if you click it, nothing really happens. It just tries to go over to the home page. Now, it looks like something broke right here, so I'll try to reload my application, but it doesn't want to do it with the letter R, so I'll stop the server from running, and then I will rerun npx expo start clear to just rebuild it. And then I'll be able to reload it. And if it still doesn't want to reload it, like is the case on my end, you can just close and reopen the Expo Go app. And this will then rebundle it. Perfect. Now, what are we going to do about the sign up page? Thankfully, it's going to be more or less the same as the sign in. So just go ahead and copy this entire sign in page, head over to sign up, and just paste it over. Immediately, it'll start looking the same, but now we're going to make some changes. First of all, I'll rename it to sign up right here, as well as here at the bottom. Then the form on the sign up will have one additional field, and that'll be the name of our user. So I'll add name right here. At the start, equal to an empty string. Then we'll have the submit function where we also have to check for the name. So I'll say if there is no form.name or these other fields, throw an error. Here we have to call the Appwrite sign up function. And then we have our inputs. More or less, it's going to be the same, but we want to duplicate an additional one just above. And this one will say enter your full name. It'll render the form.name, and it'll modify the name within our state. The label will be full name, and we don't need the keyboard type. Default is fine. So now if you head over to sign up, you can see that now we have 3 different inputs. The second 2 will remain the same, as well as the button, but we want to change some things right here. Instead of saying don't have an account, I'll say already have an account. If that is the case, well, go ahead and sign in. So now we can switch between sign in and sign up. Let's just make sure that this button says sign up as well. So now check this out. We have a fully functional UI layout built for 2 of these auth pages that share the same header, but their actual page details and the components within them are different. Here we're actually reusing very cleverly 2 different components to form 2 of these pages. Now let's go ahead and test it a bit. I took my phone in my hand and I'll start typing. If I try typing something like Adrian, that works. Then we can actually swipe down, see this, to expand and be able to see other fields. I'll enter my email. Let's do it right here. And then finally, you can enter your password, which by default will be completely hidden. Cool stuff, right? But if you forget one of these fields and try to click sign up, you'll see user signed in successfully. Where is this coming from? I'll search for signed in successfully. And for sign up, we actually have to change it to say user signed up successfully. And this should actually not be getting executed if we don't have access to these fields. I think I might have forgotten to put a return here, because if we return, then the rest of the function will not carry out. And we have to also add it to sign in right here. So now, if you try to click on a sign in button, if you haven't yet entered your fields, you'll see please enter valid email address and password. And if you actually type something in, let's try to do something like this and a regular password, you can see user signed in successfully, and it tries to redirect you to home, but then we just automatically redirect back to sign in, which means that everything is working. This is amazing, right? You've successfully implemented your first 2 Auth screens. In the next lesson, let's implement the Auth functionality. Okay, now that we have the UI, let's also go for the functionality. Head over into our lib and then appwrite.ts file. Here, we'll need to create a function that creates a new user account, their session, and also stores them within the database as soon as they create an account. So let's first start by creating a new Appwrite client and then exporting it so that we can use it anywhere within our code. You can do it by saying export const client is equal to new client coming from React Native Appwrite. Then we have to configure this client. You can do that by saying client dot, and then you can call different methods on it, such as dot set endpoint. And you can set the endpoint to be equal to Appwrite config dot endpoint. You can then chain additional methods such as dot set project and make it equal to be Appwrite config dot project ID. And finally, you can do the same thing for the platform. It looks like it's complaining about a project ID not existing on the Appwrite config, but here it is. But it's saying that sometimes if these are coming from environment variables, they might be undefined. So since we already know that they are actually there, I'll just add an exclamation mark at the end to let TypeScript know that we know those values exist. Or you can also add exclamation mark here. Perfect. Now, alongside setting up the Appwrite client, we can also set up different Appwrite functionalities, such as export const account is equal to new account coming from React Native Appwrite, to which we have to pass the client we just created. We can do the same thing for the databases by saying export const databases is equal to new databases client. And of course, don't forget to import databases coming from React Native Appwrite. We can do the same thing for the user avatar by saying const avatars is equal to new avatars, to which you can pass the client. And now we're ready to create this function that creates and registers our user. We can do it by exporting a new asynchronous function. So export const create user is equal to a new asynchronous function that looks like this, and it'll accept a couple of props. What do we get when we're trying to create a user? Well, we get the email, the password, and the name. And these will be of a type create user params. Oh, it looks like I misspelled it. This was supposed to be params. So I'll fix it here as well. Perfect. Create user params. Then within it, we can open up a new try and catch block. In the catch, we can get an error. And if there is an error, we'll simply throw it by saying throw new error, and we'll say error as string. So we know what is the type of that error. In this case, abbreviated as just E. But in the try, we can first create a new account on Appwrite using the new unique ID, email, and password. So say const new account is equal to await account instance dot create, and now we have to pass a couple of props to it. First, you have to pass the user ID of that new user. We could just randomize it or let our cat walk over the keyboard, but our cat won't be here for every single user, so we have to find a way to generate it randomly. We can do it using Appwrite's ID functionality. So just say ID, imported from React Native Appwrite, and then use the unique method on it, which will always generate a new unique ID. You can then pass additional things to it, such as the email, password, and the name. Then, if a new account for whatever reason wasn't created, we can check that and say if no new account, then simply throw a new error like this. But if an account has been created, then we can try to automatically sign our user in after the account creation process by saying await sign in. And this is a function that we have to create, to which we'll pass an object containing the email and the password. It's a separate function that we'll use in the create user function, as well as also using it standalone when a user just wants to sign in. That's why it has to be created separately just below. Expert const sign in is equal to this function that looks like this, and we can also just export it for standalone use outside of this file. And the type of the props here is going to be sign in params. Perfect. Now, after we try to sign the user in right here, after we create the new user account, all of this so far has to do with just authentication functionalities. But remember that chart that I showed you before, where I drew a couple of rectangles and explained the steps? Well, there I said that at one point, we also need to create a user within the database so we can more easily work with different relations. So let's create a new database user by saying const new user is equal to await databases, which we are importing right here from the top, dot create document. And now the way that the create document method works is first you have to pass the database ID. And where do we have access to the database ID? Well, it is right here under Appwrite config. So just say Appwrite config dot database ID. The second prop will be the user collection ID, which we also have stored, Appwrite config that user collection ID. Then is the ID of the new document we want to create. And this one will be randomized. So I'll just say ID unique. Finally, the last param is an object containing all of the information or the data that we want to store. So I will simply pass in the account ID, which will be equal to the new account that we created above, dot $ID. Then the email, the name, and the avatar, which will be named avatar URL. And this avatar URL, we can actually create just before by saying const avatar URL is equal to avatars dot get initials URL, and we can pass a name right into it. What this does is it generates an avatar image using the username's initials and then stores it into the database. So essentially, we are creating a new user in the database with the following email, name, account ID, and an avatar URL. Everything that a user needs. And you can see how WebStorm very conveniently tells me what each one of these params does within the create document. Sure, I could hover over it and see what it does, but being able to quickly see at a glance that the first thing is a database ID, second thing is a collection ID, third thing is a document ID, and finally the data that we're trying to create, this is super convenient. And I love this about WebStorm. Finally, once we create this new user, we can just return it from this create user function by saying return new user. WebStorm is also telling me that this is an inline variable and that declaring this new user is redundant. So if you want to fix it, you don't even have to put it into a new variable. Instead, you can just say return whatever the output of this function is, which is technically just the user. Perfect. So now let's actually sign our user in by creating the user session within this second function by opening up a try and catch block. In the catch, we can get the error and we'll throw it by saying throw new error e as string in case something unfortunate happened. Else, we'll create a new session for our user using their email and password by saying const session is equal to await account.create email password session, to which we have to pass the email and the password. We have everything we need. And once again, WebStorm nicely fills it out. It's not as useful because we are sticking to very good coding practices and naming our variables properly. But imagine if we were passing some regular strings or numbers here. If we did it like that, you would still be able to know that this is an email and that this is a password. Thankfully, with our proper coding, it's less relevant, but still good to have, just for final checking. Great. So now, finally, within our sign up screen, remember where we were? That was in signup.tsx. We are ready to call this new create user function we just created. So after set is submitting to true, within the try, I will now await create user, import it from where it needs to be imported, and to it, I'll pass an email equal to form.email. I'll pass a password equal to form.password, and I'll also pass the name equal to form.name. Now, we are duplicating ourselves a bit here, so what you could do is just destructure these fields from the form object by destructuring name, email, and password from the form, and then you don't have to repeat yourself. You can remove all of the mentions of the word form and instead just refer to their variables. And since the keys and values are duplicated, it also means that you don't have to say it for the second time explicitly, which allows you to have a much cleaner function that looks something like this. This is not a part of React or React Native. This is just good old JavaScript. So if you'd like to polish your JavaScript skills, on jsmastery.com, we have a terrific complete path to JavaScript course that dives deep into optimizations, just like this one. But with that said, once we create the user, no longer do we have to do an alert. Instead, we just want to bring the user back to the homepage because now they've been fully logged in. So what do you say that we actually test it out? I'll now pick up my phone, head over to the sign up function and create a new user. I'll call myself Adrian. For the email, I'll use adrian@jsmastery.com. And for the password, I will use 123123 and I'll sign up. It says, oh, this is not going to work. The password should be at least 8 characters long. Okay, I got you. I'll just add one more 123. And now if I click sign up, it's loading. It says the current user is not authorized to perform the requested action. Oh, okay. You know why this is? We have to head back over to Appwrite and go under user settings. This is under databases, user settings, and give this user additional permissions. For now, I'll leave it as any, and I'll give it create, read, update, and delete permissions. So we can actually call the create method on this collection. If you do this and then retry clicking the button, it'll say a user with the same ID, email, or phone already exists in this project. Okay, that sounds good. Let me actually then go back into the auth and check it out. Oh, it looks like it got created the first time because the authentication succeeded, but we didn't have database permissions, so that's why it failed. So what I'll do is I'll remove this user from auth by scrolling all the way down and clicking delete. And I'll just retry it one more time. Should succeed now by clicking sign up. It's loading and we got redirected. And check this out, we get some native mobile functionalities. It's asking me whether we want to safely store the passwords in the password app. I'll click not now. But with that in mind, if you now head over to Appwrite auth and reload, you'll be able to see that we have one new user here with their ID, name, email, and we can add some additional options if we want to. Pretty cool, right? But we're not just creating this user within the auth, we're also creating this user within databases. So if you head over to databases, app, user collection, you can see that a new user called Adrian with the email and account ID and the avatar has been created. So now if you try to visit this user's avatar, you can see JM as in JavaScript Mastery. Amazing. It means that we have successfully created a user. Similarly, we can head over to the sign in, and here we can call the sign in functionalities. So once again, I will destructure the email and the password from the form. Also notice how the autocomplete is working very nicely with WebStorm. I will remove the mentions of the form object. And then right here, I will just call the Appwrite sign-in function by saying await sign in. Don't forget to import it. And within an object, pass in the email and the password. We don't have to have the name because the name gets entered once the user signed up. And I'll remove the alert. So now if you test it using the same credentials that you entered before, for me, that was adrian@jsmastery.com and a password of a couple of times of 1 to 3. Now, if you click sign in, you'll see that it says Appwrite exception, creation of a session is prohibited when a session is active. This is because when creating a new user, we automatically called the sign in function to create a session for that user. You can change any of these session-related settings and even add restrictions for the password within Appwrite Auth Security. So here you can choose the limit of the users, the session length in days, the limit, password history, how many times you can change it, password dictionary, so that actually prevents the user from setting insecure passwords by comparing the user's password with the 10,000 most commonly used passwords. What do you think? Would my 1 to 3 pass? I don't think so. But yeah, there's a lot of stuff that you can do right here, all directly implemented within Appwrite. And now that sign up and sign in are in place, let's write a function to get the details of the currently logged in user. So we'll do it within the same file. That's going to be the appwrite.ts. I'll collapse these two functions that we have created just to have a bit of a cleaner working space. And just below, I'll create a new function, which I will call getCurrentUser. Export const getCurrentUser is equal to an asynchronous function, and it's not accepting any parameters. We'll get the user from the session that's currently logged in. So I'll create a new try and catch block. If something goes wrong, I think you know what we're gonna do. We'll just console log that error and maybe throw a new error, e as string. But if everything is going well, we can just try to get access to the current account by saying const current account is equal to await account.get. If there is no current account, we'll throw a new error. But if there is an account, we'll try to fetch the current user from the database by saying await databases.list documents. The way in which you can list documents within Appwrite is by first passing the ID to your database, which we have stored under appwriteconfig.databaseID. Then you have to pass the ID of the collection you're trying to fetch the user from. In this case, it is our appwriteconfig.userCollectionID. And finally, you have to pass the query. A query can be a list of queries within an array where you can say query.equal. This query, you have to import it from React Native Appwrite, .equal account ID. We want it to be equal to the current account $ID. Finally, if we didn't successfully fetch a new user, just throw in an error. But if we have, then return the current user .documents 0, because we only want to return one user that we fetched. Perfect. So now we have a function that allows us to get the current user. So that allows us to get this information and redirect the user to the right screen. If, for example, a user is already logged in, they should be redirected to the home screen. But if they're not, they should be redirected to the sign-in page. Now, instead of calling these functions separately on every single screen, like the auth layout or the cart, profile, search, or tabs layout, what I'll do instead is I'll call them just once and store the result in a shared state. Then, whenever we need the information about the currently logged in user, we'll retrieve it from the state. This approach will help us avoid making multiple requests to Appwrite, which will further improve the performance of our app. Now, just before we start implementing that global state that allow us to improve the performance of our application and finally start testing some of these server actions and backend calls that we implemented, I want to take 5 minutes to implement a tool that'll save us hours of time later down the line. And the tool is called Sentry. They recently implemented Seer, a debugging agent that knows why your code sucks. But in other words, Sentry is an application monitoring software considered not too bad by 4 million developers. And the best of all is, it doesn't just work for web applications, but also mobile. In the description down below, I left a special link that will allow you to sign up and see exactly what I'm seeing so you can follow the setup properly. And alongside the way, you'll also get 50,000 free errors with the JS Mastery code. So just head over here and create your account. Once you sign up, you'll be redirected to your dashboard. There's a lot of stuff to explore here, but first we gotta hook up Sentry to our project. So what better way to do it than to check out the docs? Thankfully, Sentry has dedicated docs for React Native applications, and there's a special expo setup. And I'm super excited as of recently, Session Replay is now generally available for mobile devices too, not only web. So let's go over this setup and let me teach you how you can set up Sentry with your React Native application. In this case, we'll go with the automatic install using the Sentry wizard to automatically set everything up. So let me just copy this command, open up my terminal right here and paste it. npx add Sentry/wizard add latest -i React Native. Press Y to install the package. Now it's gonna say that you already have some files right here. That's totally okay with me, so we can just continue anyway. It's now installing the Sentry package, and it's asking you whether you wanna use Sentry SaaS or self-hosted. In this case, I'll go with Sentry SaaS, Sentry.io, and it'll ask you whether you already have an account. I'll say yes, of course, because we just created one, and we want to authenticate with it. So in the browser, it'll open up a new selection of your project once you authenticate, and you can then choose whether you want to take some of the existing projects or you want to create a new one. For this one, I'll create a new project and call it JSM_React Native food ordering and click continue. Once you do that, you'll be able to return to your terminal to complete the setup. And it's going to ask you whether you want to enable session replay. So that's going to be a strong yes. I was waiting for a long time to have this enabled on mobile devices. It's going to ask us, do we also want to enable the feedback widget? I'll say yes to that as well. And it just auto-applied the changes and even added a button that will trigger our immediate error. So it says the snippet will create a button. When tapped, it'll send a test event to Sentry. After that, you can check out your project issues here. So let me actually click on it immediately to open it in the browser. There we are. It looks like there are no issues yet. So now, once everything is set up, let's go ahead and copy this snippet so we can add it to our application and head over into App, Tabs, and then Layout, and set is authenticated to true. Refresh by pressing R in the other terminal, and you'll be redirected to the home screen. Then head over to Tabs, index.tsx, and add that button that throws an error that will be captured by Sentry. This way we'll know whether Sentry is working or not. So right here below the list header component, we can also make use of a list footer component that accepts a callback function. And the only thing we want to return within here will be that button with a title of try. On press, it'll execute an error, and then we can close it. Make sure to import the button component from React Native, and also make sure to import everything as Sentry coming from add Sentry/React-Native. Perfect. Let me also organize these imports by internal and external, so it makes a bit more sense. There we go. And now at the bottom, you should be able to see a button that says try if you scroll down. Here it is. As soon as you click it, it seems that nothing happened, but if you head back over to your Sentry's dashboard, you'll see that an event was received. So you can either reload or say, take me to my error. And here you can see all of the information about this error. You can even see the device that I'm using, iPhone 13 Pro Max. You can see my operating system, iOS 18.6. You can see that it was done in development and with JavaScript. You can see that the event happened 2 minutes ago. You can maybe rate it as a high priority event assigned to a specific developer. What matters even more is that we get an entire stack trace of this error, saying splash module internal maybe hide async is not a function. Okay. And then you can see how it happened through a trace preview and more information about this error. Now, the reason why I and so many other developers love using Sentry is because, let's be honest, if a user comes upon an error on your site, they're not going to give you any context or details. But here you can get so much data about the error, and you and your other developers can easily go ahead and just fix it. And of course, how could I not talk about Sentry's new feature, which is called Seer, which allows you to explore potential root causes and solutions. So just click this button right here, find root cause, and enable Seer, which is Sentry's AI agent that'll help you troubleshoot and fix those problems even faster. So I'll go ahead and enable it. And then you'll have to configure the repos that Seer can have access to. So I'll click configure repos, and you'll need to add a new repo by clicking manage repositories. By adding a new repository to start tracking commits, head over to GitHub configuration, click add installation, and then here you'll be able to add your organization, or if it doesn't exist yet, just go ahead and connect it. Click install, and it'll be right here. So you can start adding your first repository. In this case, it'll be food ordering. So try to find it and add it right here. But of course, you have to give Sentry access to it through a couple of screens that I was just showing you about a minute ago. So now Seer has access to the food ordering application, and we can head back to using it. So just click working repos, add repo, and select food ordering. This is also a perfect opportunity to turn it on for our entire course platform. I've been waiting for Seer for such a long time, so glad it's finally here. And now Seer will be able to create an analysis of all the incoming issues, and it can also provide automated scans and fixes. So if we head back to where we were on the error that we triggered, oh, it looks like I was on another error that got triggered. So it wasn't just the default one. Interesting. For this one, we have even more information. So now if you click find root cause, since we have enabled the repository access, we can now unleash the automation. So let's just enable it by saying automate issue fixes, and you can choose how aggressive you want it to be. You can make it work only on the most actionable issues, or maybe all issues. It's totally up to you. For now, I'll automatically run it for moderately actionable issues. And now Seer will scan all of our issues and highlight the ones that are likely to quick fix. So I'll say star the recommended view. And here's what Seer says. It says, what happened? Button on press triggered an error in React Native's Pressability.js. The core issue is missing function in a Splash module. In the trace, other session issues also point to Splash module functions being undefined, specifically internal prevent auto hide async and internal maybe hide async. Initial guess is that the Splash module may not be properly initialized or linked in the React Native environment, leading to its methods being unavailable. This is super useful and just allows me to go ahead and fix it immediately. We'll explore it later on a couple of other issues. But now back to the app. Let's remove this button that triggers a fake error, and instead, we'll head over to our sign in page. Here, we'll manually capture an event using Sentry. For example, if the sign in fails. So right here under catch, alongside just alerting an error, we can also capture it by Sentry. So I'll say Sentry and make sure to import everything as Sentry coming from Sentry React Native. And I'll say Sentry dot capture event, and I'll capture the error event in this case. Now, if we head back over to our tabs layout and turn the is authenticated to false so we can see the sign in, Now, before I go ahead and test it out, I can finish this installation process by saying, yes, I have successfully sent a test event, which means that everything is set up. So now I'll try to log in once again with my credentials. But keep in mind, the session is currently active, so we should get an error saying that we should not be able to log in 2 times. So I'll click sign in. We get an Appwrite exception. Creation of a session is not allowed when a session is active. Okay, we knew that. But now imagine if it wasn't us that got that error, but some of our users. And if it weren't for Sentry, we would never be able to know that it ever happened. But right now, if you head over to Issues, check this out. We have an unlabeled event. So what do we know about this error? Well, as before, we're getting back all of the information about this error, and we can see that the error happened when trying to make a request to account sessions email, where we got a 401 error. If we open up Seer to find the root cause, it says that app triggers 401 unauthorized error on Appwrite API calls, indicating authentication failure. The authentication token used for Appwrite requests may be expired, invalid, or missing. Perfect. This makes a lot of sense. And then we can just archive it or mark it as resolved. You can now go ahead and add Sentry event capturing throughout the entirety of the application that we have so far and in the future. Maybe for the sign up, for adding items to the cart, for the layouts, whatever it is, you can track it using Sentry. And this is just the tip of the iceberg of how Sentry can help. Right now, we have limited data on Sentry because we haven't yet finished our application. So to get to that, first, let's build more features, and then we'll revisit Sentry from time to time. In the next lesson, let's focus on implementing that global store that allow us to track the states across the entire application to improve performance. Now that we've implemented authentication and integrated Sentry for monitoring, the next step is to implement the store functionality. This will allow us to locally store the logged in user information and access it throughout the entirety of the app, no matter where we are, without needing to make additional requests to the server, in this case, Appwrite. In React Native, store management can be handled using libraries like Zustand, Redux, or just React Context API. They're all made to solve the same problem, maintaining the global state across the app. And in this course, I'll teach you how to use Zustand. Why? Well, it's a great choice because it's lightweight, minimalistic, and has a very simple to understand API with zero boilerplate. No reducers, action types, or a lot of that stuff that Redux just throws at you. It's just plain JavaScript. And unlike context, it avoids re-render issues and is better for performance. So let's go ahead and simply install it by running npm install Zustand. I'll do it within my second terminal, and it should be installed within a second. Then we can implement it by creating our first store. Let me zoom this up for you so you can see it a bit better. And a store in Zustand is nothing more than a simple hook. You can put anything in it, primitives, objects, and functions. And then the set function merges the state. So let me copy this from the Zustand docs and create a new folder right here, which I will call store. And within store, we can create different types of stores. So the first one I'll create will be called auth.store.ts. And here I'll paste this new store that I just created. And then the next step is to just use this store within your components. You select what you want to get and you use it directly within your application. It cannot be simpler than that. And actually, that's it. This is the end of the Getting Started page. So let me show you how we're going to make it work with our use case. First things first, I'll do an additional thing that is not required, but it'll help us with auto-completion and preventing bugs by ensuring consistency of our types. And that is to create a type, which I'll call auth state, and I'll declare it as an object. Now, this object will contain a couple of properties, like is authenticated state, which will be of a type Boolean. It'll contain the actual user, which will be of a type user, coming from @/type, or if we haven't yet created it, it can be set to null. Next, we're going to have the loading state, so is loading, which will be set to a Boolean. And then we can also have a couple of setter functions, like set is authenticated, which will be a function that accepts a value of a type Boolean. Is the user authenticated? Yes or no. It says the state and returns nothing, a void. We can have one for setting the user. So say set user, user of a type user or null, and then returns void. Finally, we can have one for set loading, where it's going to accept the loading value of a type Boolean. And finally, we can have one that'll fetch the authenticated user, and this will be a function that will result in a promise. So we can then extract the user from that promise. Perfect. So now that we have our auth state, we know what we're working with. So let's create our new store. Instead of just calling it use store generic, I'll call it use auth store because it'll contain our authentication data. And that'll be equal to create a store of a type auth state. So we can pass it like this. And then we have a callback function where we can set and automatically return different values. In this case, the values won't be Zestan's example of bears. It'll be what we set out to do. The initial is authenticated state, which will be set to false. We also have the user of a type null by default, is loading, which will also be of a type true by default. Now you can see how everything is red, and that's because this is not matching the additional fields. And TypeScript is really useful here because it's going to save our ass later on. Next, we can also set the setter function for updating the isAuthenticated value to the store. So we can say set isAuthenticated, which will be a callback function that accepts the value. And then we use Zestan's setter to set it to be equal to an object with the isAuthenticated value set to whatever the value we pass in, either true or false. We can also do one for setting the user, which will be a function that accepts the user value and calls the setter and sets the user within an object. We can do another one for set loading, and this one will also be a function that accepts a value and then ultimately just calls the setter and then passes the isLoading to the value that we want to pass. And finally, we're missing the one where we want to fetch the authenticated user. So I'll say fetch authenticated user will be equal to an asynchronous function, but this one will be just a tiny bit longer because we actually have to do just that. Well, fetch the user. So I'll say set isLoading to true because we want to start loading to fetch the user. Then I'll open up a new try and catch block. In the catch, I will console log the error by saying fetch authenticated user error and then console log the error itself. And I will also set the isAuthenticated state to false because something went wrong, and I'll set the user to null. And finally, I want to set the isLoading to false. But if everything is going well, then we can try to fetch our authenticated user, and we can do that by saying const user is equal to await get current user, and this is a server action that we created within lib Appwrite. If you remember, it is right here. And then we can just check if we have successfully gotten back the user. So if user exists, then we can simply call the set method to set the isAuthenticated state to true, and also to set this user to the state as user, so it has that proper type. Else, we can simply set the state to be isAuthenticated false and user set to null. Hopefully this makes sense. So we're doing some extra work right now, but now we have access to this use auth store, which we can call from absolutely any component or screen within our application. And any component at any point in time can get access to this state to determine whether a user is logged in or not. Do you remember where we hard-coded that? Well, it's going to be within app layout.tsx. This is the general layout inside of which we're setting up Sentry, as well as loading up some fonts. For now, I will collapse this part, and we can focus on just fetching the state. So right at the top, I will say const, and then destructure the isLoading state alongside the fetch authenticated user, and this will be equal to the hook that we have to export from the store. So right below this use auth store in auth store TS, don't forget to actually export default the auth store, and then you'll be able to call it as a hook, use auth store right here. Once we get those two, you should be able to just add a new use effect below this use effect above. And what you can do is just fetch the authenticated user. Here it's mentioning that the promise returned from the fetch authenticated user is ignored, but that's totally okay because here we're not concerned about this return. Rather, once we call this fetch authenticated user function, it'll actually set the isLoading state properly. So in this case, all we care about is that state, so we can check if not fonts loaded, or if still loading, then don't return the screen. It means that we still haven't finished the necessary actions in order to be able to load the screen. And then the second place where we can add a redirect check for a non-authenticated user, now very easily using this auth store, is where we initially mocked that data. It's within app, tabs, layout.tsx. Here, we just hard-coded it, but now it's super easy to get a real value by saying const, destructure the isAuthenticated field, and make it equal to the hook call of the use auth store. And now this is referring to the real value. And if your component name is _layout right here, then you can change it to something like tab layout in this case, because that follows the proper React guidelines for naming components, and therefore it knows that it can accept some hooks right here. Perfect. Similarly, we can now head over to our auth layout and also implement this check. This one is maybe even more important because, hey, we're now looking at a auth screen, but we're actually logged in. At least we should have an active session from when we logged in the last time. So right here, I can just say const is authenticated is equal to use auth store, and then we can check if is authenticated is true, then we can just return the redirect over to /, meaning the home page. And you can also rename this to auth layout. So now if you save it, you can see that we automatically get redirected back to homepage because our user is actually logged in. If you haven't, you can log in and everything should work properly. To test this out, you can add a console log in the home screen to see if there's actually a logged in user. So if you head over to tabs, index.tsx, you can now very easily extract this real user from the auth store by saying const destructure the user from the call to the use auth store hook. Make sure to import it. And then you can just console log the user like this. And this user typically contains a lot of data, but you should be able to see it within the terminal. In case you want to be able to see it in a bit of a more structured format, what you can do is say console log user, and then you can JSON.stringify this object by saying JSON.stringify user, pass null as the second parameter, which is a replacer, and then 2, which is for the spacing. So if you do it like this, you should be able to see a very nicely spaced log for your currently logged in user object with all of its permissions, database and collection IDs, avatar photo, account ID, and more. Perfect. So now we can get access to this user from every single screen within our application. This is exactly what we wanted to achieve. And doing that with Zustand, as you can see, is super simple. You just have to declare this, I would even dare to call it a global object, and you can just use it whenever without having to repeat all of these calls in every single page. You just call them once, or you call them whenever you need them, and it serves you the data on the platter. And with that in mind, you now know how to implement a global storage or state solution in your React Native applications using Zustand. Great work. In the next lesson, let me teach you how to implement a tab navigation. In this lesson, I'll teach you how to implement the tab navigation, something that every single mobile application needs to have. But not only will I teach you how to implement it for this React Native application, you'll also learn how to implement it within any of your future React Native apps. So let's dive right in. There are different types of navigation, one of which is tabs. Expo makes using this tab navigation even easier. Tabs are the most common way to navigate between different sections of an app. Expo Router provides a tabs layout to help you create a tab bar at the bottom of your app. And the fastest way to get started is to use a template. So check it out. You can get started by creating a file-based routing system. We have already done that. And then after that, you can define different screens like this. And then through tabs, you can switch between those different screens. But let's stop looking at the docs and let me show you how you can implement it. Head over within App, Tabs, Layout.tsx so we can implement the tab navigation as per our design. First things first, instead of returning the slot, I'll actually be returning the tabs component coming from Expo Router. It'll look something like this, and we can more nicely structure it like this if you want to. Within tabs, we'll also have different screens. So we can immediately create a tabs.screen to which you have to give specific properties. For example, you can give it a name of index. This is going to be for our homepage with some additional options. Options like, well, you just saw that what popped up on the screen. There are many different options you can pass in, one of which will be a title. So we can say home. And now if you save it, you'll immediately see that we get all of these different tabs automatically created for us, even though I only specified one. Why can we immediately see cart, search, profile, and why do all of these immediately work? Well, that's because Expo, like Next.js, uses a file-based routing system. So as you can see here, it automatically recognized all of these different routes within the tabs layout. But now is the time to actually make it look good. So alongside the title, I also can provide a tab bar icon, which can recognize between two different states, focused or unfocused. And for each one, we want to automatically return some kind of a tab bar icon. For now, I'll leave it as a self-closing component. And I will now create this new component right here at the top so we can reuse it for all of the different icons. Const tab bar icon is equal to a callback function that accepts a couple of props, such as the focus state, the icon, and the title. These are of a type tab bar icon props, and we can automatically return a view. What do I mean by automatically return? It means that I'm wrapping this in regular parentheses and not a curly brace, because that would open up a function block. If you did it that way, which you can do, you would then have to explicitly specify a return. But if you just do automatic return, then you can just immediately typing what you want to have here. In this case, it's going to be a view with a class name of tab icon. Within it, let's render an image. This image will have a source equal to icon that we pass through as props, with a class name of size of 7, with a resize mode of contain, as well as a tint color, which is going to be different depending on whether it's focused or not. So if it's focused, the tint color will be hash FE8C00, else it'll be hash 5D5F6D. I found those two colors to work well. Below the image, we can also render a piece of text, and this text will simply render the title that we're passing through props. So why can't we see anything for the homepage yet? Well, that's because we have to pass those additional props to this component that we created. So I'll pass the focused state equal to focused. I'll also pass at the start the title equal to home, and I'll also pass the icon equal to images, which we need to import from constants, dot home. So now if you save it, you can see that we have a special home icon appearing right here. We can further style the text right here by giving it a class name equal to. I'll make it dynamic by using a CN property. And then it'll always have a text SM and font bold, but only if it's focused, then it'll be text primary, else it'll be text gray 200. Perfect. But hey, why is it saying home 2 times right here? This isn't really looking the best. Well, right within the tabs, we can pass so many different props that alter how the tab layout looks like. For example, we can pass the screen options, which is an object, where we can say header shown and set it to false. We can also do something like tab bar show label, set it to false as well. And if you save it, now it's much easier to look at this home. And we can also pass this tab bar style. And within here, you can pass many different styles. For example, a border top left radius of 50. Yeah, see how now we have made it a bit more round. We can repeat this a couple more times for the top right radius and also for the bottom left radius, as well as the bottom right radius. So this will now make it much more rounded and much more natural, making you want to order some food, I guess. We can also set the margin horizontal to about 20. We can set the height of the tabs to 80. We can also set its position to be absolute, so it appears like it's floating. We can also set it to be 40 pixels from the bottom to move it a bit up. We can give it a background color of white. We can also give it a shadow color of something like hash 1A, 1A, 1A. We can also give it a shadow offset, and this will be an object with width 0, so 0 offset on the width side, but the height offset will be set to 2. Let's also give it a shadow opacity to about 0.2, or 0.1 I think should be enough. Yeah, now it's floating. We can give it a shadow radius of something like 4, and we can give it the elevation of something like 5. And now it really appears like a real floating tab bar right here. Looking pretty cool, right? I'll collapse those screen options for now, but you get the idea. Within the tabs, we can pass all of these different props that style how our tab bar looks like. But now we have to duplicate this tab screen for all of the different pages, so we get custom ones and not these default carrots. So I'll just duplicate this 1, 2, 3 more times for the other 3 of our screens. I'll change the second one to, let's do search with a title of search. And here you also have to change the title of the icon as well as the image. So that'll be images.search. The next one on the list will be set to name of cart. Oh, and we can start the name here with a lowercase s. The cart will have a title of cart, you can guess it. It'll say icons.bag or images.bag with a title of, let's do cart. And for the last one, we can do profile, which is going to be our profile page with a title of profile, name profile here as well, and pointing to images person, indicating a profile. So now you can see 4 different icons with 4 different pieces of text, and this is actually looking great. Not only that, but using this focus state that Expo handles for us, you can immediately see that as you move through different screens, and it is moving even though nothing is showing, that's because we haven't yet implemented those screens, you'll also change the active page that we're currently on. So if we're in the home page, we can see everything else, and it feels like the tab bar is actually floating in space, or on the screen, should I say. Perfect. So now you've implemented not only the file-based routing, but also you'll learn how to implement the most popular navigation in mobile applications, which is the tab navigation. That's definitely worth a commit, so I'll commit it right here by saying git add dot, git commit -m, implement full auth, that's because I forgot to commit before, as well as the tab navigation. And git push. Perfect. You just got one step closer to our final application. Okay, we have the homepage UI, but the real work begins right now, because now we're starting to dive deeper into the functionalities of our application. We can't just have a static screen. So let's talk database architecture. When designing a food ordering app like this one, we have to think in terms of how a real restaurant or a real food ordering app works. A user doesn't just order food. They look through different categorized sections, like burgers, pizzas, or burritos. So the first concept that emerges here that we have to think about in terms of the database architecture is a categories collection. Each category has to have a name, like burgers, and a short description. This will allow us to organize the menu and make filtering easy on the front end. So head back over to Appwrite Cloud and head over to Databases. Open your database and create a second collection within it. This one I'll call Categories. As with a users collection, we'll have to give those categories a couple of attributes. So let's create a first one, which will be a string of a type name with a size of about 100, and it'll be required, which will contain the name of that category. Then we can have another string, which will be a description of a size 100, which we'll also make required. Now, don't forget to go to Settings and head down to Permissions, and you could either turn it on for any, but in this case, you can update the permissions to allow operations from the user. So simply say all users, and then give them all permissions. This should be enough. Then copy the categories ID and add it to our Appwrite config. That is right here under user collection ID. I'll add a categories collection ID and just paste the ID I just copied. Now, the main part of the app aren't the categories. It's going to be the food itself. Every individual food item, like the Wendy's burger or a margarita magic, or even this chicken wrap. Each menu item has to have properties like a name, description, image, price, rating, and even nutritional info. It also needs to reference the category to group the items into the right section. So head back over to Appwrite and create yet another collection called Menu. Within Menu, you can also create a couple of additional properties or attributes. So let's create a first one that'll be a string of name. We can make the size of about 200 and required. Let's also add a description, which will be another string of a size 2000, can be a bit longer, and I'll make it required. We can also add a URL with an attribute name of image URL and required. I'll also add a float. A float is a number which we can use for the rating. So it can go from 1 to 5, and I'll make it required. Next, we can add an additional integer, which can maybe be a number of calories. So I'll enter the min size of 1 and max size of like 10,000. I doubt an item is going to go above that. And I'll also make it required. Now we can go even further and add things like an integer for the macronutrients like protein. I'll set the size from 0 to 10,000 and also make it required. And I'll add another float for the price with a price of 1 to 10,000 and make it required. Finally, we need to create a relation between the menu items and the categories. So it's right here, relationship. It's going to be a two-way relationship with the categories collection, where the attribute key is going to be categories, and the relation will be set to many to one. Oh, and this attribute key in the related collection will be set to menu. So now we have categories, attribute key of categories, attribute key is menu in the related collection, and then a relation many to one, because one menu item can contain one category, but categories can belong to multiple menu items. And when we delete a document, we can set it to cascade to also delete all the related documents and create. Now go to the settings of the menu collection and let's also update the permissions. We can also give permissions to all the users and give them full permissions. Don't forget to copy the collection ID and add it to the code right after the categories collection ID of menu collection ID and set it to the string you just copied. Now, real-world menus are also rarely static. Most food items come with optional choices like extra cheese, fries, Coke, or olives. These are called customizations. But instead of hard-coding them directly inside of each menu item, we can create a separate customizations collection. So let's create a new collection and call it customizations. Now, each customization can include a name, a price associated with it, and a type, such as a topping or a side. This approach will allow us to reuse customizations across multiple menu items. And if fries become $5 instead of $3, you update it once and every menu item using it will automatically reflect the change. So let's give them our first attribute, which is going to be a name, about 100 characters and required. We can also give it an integer for the price or a float, either way should work. It's going to be from 1 to 10,000, just not to limit our users in case they want to go crazy with the pricing. We don't care about that, we're building the app. And finally, we can also create a type. And that can be of a type enum. Enum allows you to choose between a set of predefined options. So for example, it can be a topping, or it can be a side, or a size, or crust, or bread, or spice, or base, or sauce, or something like that. Whatever you want, you can add it right here. And then your users will be able to select it within the app. And let's make it required and click Create. Now, let's go to the settings of the customizations collection and let's update the permissions to give the users the ability to create them, read them, update them, and delete them. And let's copy the customizations collection ID and paste it over right here. Customizations collection ID. And we can paste it right here. Great. So you might think that we have everything we need, but there's one challenge here. Some customizations apply only to burgers, but not to pizzas, for example. Others apply to both. This is a classic many-to-many relationship. A menu item can have many customizations, and a customization can belong to many menu items. And in relational modeling, the cleanest way to handle this is by introducing a join table, or in Appwrite's case, a new collection. This collection will be called menu customizations and is essentially a joined table. It'll contain pairs of references, one pointing to the menu item and the other to the customization. This architecture will keep the data clean, reusable, and consistent. For example, a user might add a pepperoni pizza with extra cheese and a Coke to the cart. And because these customizations exist as separate documents, the app doesn't duplicate that information. It simply links them. I mean, you could say that you could embed customizations directly within the menu items that we create in our database. It's a tempting shortcut, but it quickly falls apart as the app grows. Because embedding customization makes it hard to update prices globally, leads to inconsistent naming, and makes filtering or analytics harder. By normalizing data, separating it into reusable collections, this structure is more scalable and maintainable. There's also flexibility built into this design. Customizations are optional, and not every item needs to have a topping or a side. So even if a menu item has no customizations, it can still be stored, displayed, and priced properly. This design supports both simple and complex items equally. And this is just one of the advanced database optimizations that we teach over on jsmastery.com. This one specifically, I believe I cover within the Ultimate Next.js course, where we try to do something similar with the Stack Overflow clone application that we're creating. It has many different lessons, so I don't think I'll be able to find it right now. But yeah, we do something similar there, and I go into much more depth explaining it. So if you want to learn it in more detail, check out jsmastery.com. But for now, let's actually add some attributes for the menu customization collection. The first attribute I'll add is going to be a relationship, a two-way relationship between a collection called menu with the attribute key of menu, and the secondary attribute key is menu customizations with a relationship of many to one, and we can say cascade when we delete one of these documents. And I'll create yet another attribute of a relationship, once again a two-way relationship, but this time with the attribute key of customizations and the attribute key of menu customizations. It's going to be a many to one, and we'll also set it to cascade and create. Let's not forget to update the permissions so we can actually use it. So set all users and give it full permissions. And now don't forget to copy the collection ID, but I think you will remember that by this point. So we can add it right here and say menu customization collection ID and set it to the ID we just copied. This structure follows the standard relational database design principles while fitting naturally with how real-world food ordering works. It's designed to be clear for developers, scalable for future features, and it's also flexible enough to accommodate any kind of a food business, from a burger joint to an Italian pizza shop. If you want to expand it even further, you could add additional collections like orders, cart, addresses, while still keeping the data separated. Oh, and alongside this, we'll also need a storage solution for storing different menu images and similar stuff. So we'll also use another one of Appwrite's features called storage. Head over to storage and create a new bucket. And let's name it something like assets. Go to settings of the assets and also modify the permissions. For all users, we'll set it to create, read, update, and delete. Finally, let's not forget to copy the bucket ID and paste it over to right here below our database ID. I'll call it bucket ID. Perfect. Now, if this hasn't yet fully clicked for you, no worries. It'll click better once we actually start putting it into practice. Now, in the next lesson, I want to teach you how we can do something that you need to know when you're working with any kind of a database. And that is a concept known as seeding a database. So let's do that next. In this lesson, we'll talk about database seeding. Whenever you're setting up a new database architecture, it's always useful to be able to visualize the data that you're creating. Because think about it, if you don't yet have a form through which you can actually create the data, how will you be able to see it and interact with it on the screen? For that reason, we want to be able to see the database immediately and automatically so we can immediately test out all of these different relationships and functionalities. The alternative to that is building an entire admin panel through which you can then add menu items and other customizations. But that will go beyond this tutorial, so instead we'll do it with seeding the database. To get started with it, head over into your application where we have our lib, and right below Appwrite, create a new file and call it data.ts. Now this file will contain tons of different dummy data pieces that we can then fuse into our application. You can get it within the video kit link down below. As you can see, this file just contains a couple of different arrays within a single object called dummy data that has different categories of products with their descriptions, such as burgers, pizzas, sandwiches, and more. It also have different customizations that we can add to those products. It has also different menu items. Now, of course, I didn't go ahead and create all of these by myself. I just asked ChatGPT to generate a couple of these menu items for me. And there you have it. That's the dummy data. But now we have to put that dummy data to use within a new file within the lib folder, which I will call seed.ts. And I'll also provide this seed file right within the video kit down below. Now, what the seed file does is it takes that dummy data, creates a couple of TypeScript interfaces for it so we can be type safe, and then create a couple of functions that we can call, such as clearing the database, clearing the storage, uploading those images to storage, and then finally seeding this database. Make sure that these are called exactly as you call them within the Appwrite config, So for example, I call this customizations collection with an S at the end and menu customizations collection right here. So just make sure that these are actually matching with what you have here. Menu customizations collection. There we have it. So first things first, we clear out the entire database. Then we create the categories. Then we create the customizations. And then we create the menu. And finally, give a console log that we have successfully seeded the database. This file will also interact with the Appwrite's storage to upload these images online. So to make that work, let's head over into lib appwrite.ts and let's create an instance of storage. Here, where we have account, databases, and avatars, let's also add export const storage is equal to new storage coming from Appwrite, to which we pass our Appwrite client. And make sure to import storage from React Native Appwrite. Perfect. Now, if you head back over to the seed function, let's see if everything is good. Yep, the storage is now correct, so we should have no more issues, besides just making sure that we have properly called all of these collections, such as the customizations collection, as well as the menu customizations collection. Perfect. We're good. So now how do we actually call a script or this specific seed file? Well, we have to call it within our application. So for example, let's head over into app, tabs, and then we can do it within the search because we have nothing on that screen. Wrap it within a safe area view. And notice how immediately the text, the search actually comes down because it's within the safe area view, not within a regular view. Then you have a text of search, and just below it, we can have a button with a title of seed that when pressed, will call a callback function that'll simply call the seed function from libseed. And if something goes wrong, we'll catch the error and then simply console log that error by saying something like failed to seed the database. And then we can also console log the error as the second parameter to this console log function. So now you should be able to see the seed button right here on your phone. So just click it and open up the terminal before you do, just so we can track what's happening. Let's make sure that we don't have any issues, and it looks like we are good. And click seed. It says failed to seed the database. The current user is not authorized to perform the requested action. Okay, good that we put the error handling in place. What action are we actually talking about? It could be any of the actions here, like creating documents and so on. So if I head back over to databases, user collection, settings, and then permissions, I give all roles full permissions. We have to make sure that we haven't forgot to add those permissions for any of our collections. But it seems like users have full permissions in all of these different collections. Oh, besides categories. Looks like I forgot to do it for the categories. If you had it in there and if you didn't miss it, then everything should have worked for the first time. But I'll add it now, and I'll just try to reseed the database one more time. Let me just restart the server just to have a clean UI right here in the terminal, and I'll reload the application. It's bundled, and I will click seed. Now, don't re-click it a couple of times and actually give it some time to do its job. It's gonna actually take maybe 10, 20, 30, 50 seconds. It can even take up to a couple of minutes. But after some time, you'll get a seeding complete log, or you'll get a message that something went wrong. But for me, I got seeding complete. So we can actually verify it by heading back over to our database and now open up any of these collections, such as the user collection, where you'll be able to see that we only have one current user. But for every other collection, you should have many things within it, such as for categories, you have all of these different categories right within your database. For the menu, you have all of these different menu items and even image URLs that are stored directly within Appwrite storage with ratings, calories, proteins, price, and more. Some are related to some categories and the others are not. So for example, we can see that we have this, what is this, grilled veggie sandwich, and it is linked to this category, which is the one ending in 12A, and that is a sandwich. You can also check out all of the different customizations that we have access to. So with that in mind, we have now successfully seeded our database, and we can remove this seed button from the search because now we know that the data is there and we can actually start showing it on our search screen. So let's do that next. Now that everything is set up, let's develop the search screen and display its results. For now, it's just completely empty. First, we have to write a function to get all the menus with a search by text and filter by category ability. And to do that in Appwrite, you'll have to specify what kind of a search you want to do. Either it's a full text or it's unique. That's called indexing. So head over to Appwrite console under the menu and then head over to indexes. Here, you can create your first index. You can name it index 1 with a key of full text, and we can search by name in an ascending order and just click create. Now back within the code, specifically within the appwrite.ts file, we can now write a function to get all of these menus. I'll write it right at the bottom of the other functions we have created so far, below the get current user, and we can do export const get menu is equal to an asynchronous function, which will accept two things, a category and the query. So we can search by both. And these will be of a type get menu params. Then within it, I'll open up a try and catch block. In the catch, we will simply throw a new error as string if something goes wrong. And in the try, I'll try to first form the query by saying const queries of a type string array, because there can be multiple queries at the same time, at the start equal to an empty array. And then if the user has passed a category, if they want to try to get a menu item by category, so if a category exists, then we can say queries.push, and we can use Appwrite query functionality .equal to check whether the categories collection matches the category that we're trying to filter for. And in the same way, I'll check if a query exists. In that case, I will push queries.push query.search name with the following query that we're passing through props. And once we have those queries, we can actually filter it by saying const menus is equal to await databases.list documents. You know the deal. We first pass the database ID, then we pass a collection ID. This time we want it to be appwrite config.menu collection ID, and then we pass the list of queries that we want to filter by. Finally, we can return menus.documents. Perfect. So now we have this get menu functionality. And similarly, we can also fetch all kinds of categories from the database. So in the same file, let's also create the get categories function by saying export const get categories, which is going to be equal to an asynchronous function where we can open up a try and catch block. In the catch, we will simply throw a new error. And in the try, I'll try to fetch the categories by making it equal to a databases.list documents call, to which we need to pass a database ID and a collection ID, which in this case will be the categories collection ID. See how easy it is once we have properly stored all of these pieces of info and IDs in the right place? Now it's easier to create functions that give us exactly what we want. And you could call these Appwrite functions within a use effect, as we want to load the data on the screen, and then use the loadings and errors and all that good stuff. But that would be repetitive, especially if you have more calls to do on a single screen. So to avoid that, we can create a reusable hook that we'll use to call these functions on load, on click, or depending on different params. So let's create a new file within the lib folder, and I'll call it useAppwrite.ts. And since this is a generic function that you can reuse in any of your future apps, and I'll be honest, I used a bit of ChatGPT to generate it, I'll drop it in the video kit down below so you can actually copy and paste this function right here. But don't worry, I'll explain how it works. So everything starts with a couple of interfaces that we define to keep our application type safe. After that, we make this use Appwrite hook accept a function, which is going to be a fetcher function that fetches the data, the params we pass into that additional function, and then skip in case we want to skip the call. After that, we try to be a bit abstract with how we're defining the data. We're not saying users or menu items or categories. We're just calling it data and set data, or loading, set loading and error and set error. And then we have one single function that we wrapped into a use callback to make it even more performant. And it's setting the loadings, setting the error, and then tries to fetch the data based on the function that we passed in and the parameters that we passed in as well. Finally, it gets that data, we can refetch it with this additional function, and then we return it at the end. The beauty of this custom hook is that now we can call this data more easily instead of every single time writing all of this code for all of these different calls. But it'll start making so much more sense once I show you how we can actually call this hook in action, because then you'll understand what this fn is and what the params are. So let's actually call it within the search page by heading over to tabs, search. Right at the top, I will say const and destructure the data and make it equal to the call of the use Appwrite custom hook that we created. To it, we need to pass a couple of props. We need to pass, first of all, the function that we want to use to call the data. In this case, let's say that we want to use the get menu function we created. So the get menu is this one. So in this case, the use Appwrite hook will actually be doing whatever this function is supposed to be doing. But hey, we also have to pass some props to this function, like a category or query. Well, we can do that through this second parameter called params, which is an object. So right here, we can now say that we can pass a params of a category, for example, an empty string for now, or a query, also an empty string, or a limit. We can maybe say, hey, give me 6 items. And this is how we fetch not only the data, but also the ability to refetch that data if it becomes stale. And you can also get access to the loading of that data. So let's try to console log it to see what we get back. I'll save it and reload. And now if you head over to the search page, check this out. We immediately get back all of this great data, which are our 6 menu items. I can see some beef patties right here and cheese. That sounds good. But let's say that on this same page, we also want to fetch the categories. Now, thankfully, we can just call this use Appwrite hook one more time, just below, by saying const, destructure the data, but this time I will rename it as categories, and I'll make it equal to the use Appwrite hook, to which I'll pass the function of get categories. And this one, we're also importing from the lib Appwrite, and we don't need to pass any params because this function isn't accepting any. But if we do eventually end up having a category or a query, how are we going to fetch it? Typically in Next.js, we fetch it from the URL params. But hey, we don't have a URL here or params, right? Well, thankfully, Expo made it work in a very similar way to how it works in Next.js. You can say const params is equal to use local search params coming from Expo router. And to it, you can define the type of the params you're trying to get, such as we can say that maybe we're going to be getting a query of a type string, as well as a category of a type string. This will be within an object. So now we know that this query will contain those pieces of data, and it'll contain them because we're going to pass them over through params. I'll show you how we're going to do that. So from these params, we can actually destructure those 2 values, which is going to be the category as well as the query. So now you can say category and pass it right here. And in the same way, you can pass the query. In this case, our hook is demanding that we have those fields. So for the time being, I'll just mark them mandatory as well right here so that we're good. And I believe we can now fit this into one line nicely. And maybe even this entire call would fit into one line, just so it's a bit easier to understand. There we go. So now we're fetching all of these params, and then we have 2 calls through which we're fetching the data. The first one fetches the menu items, and the second one fetches the categories. But in case those params get updated, such as the category that we click on or the query that we're searching for, if that gets changed, we need to re-update the data. So we can do that with a simple use effect that'll, in the dependencies, have the category and the query, which means that whatever we put within this function will get recalled whenever these two change. So we can simply call the refetch function right here, and to it, we need to pass the category, the query, and the limit, maybe 6 by default. And that's it. This will refetch the data and update it automatically. So you can see how creating these custom hooks can be super useful in keeping your application clean and easily understandable. So now that we're fetching the data, and we know we are because I put a console log, we can actually develop the UI of the search screen and render that data. So I'll start by giving this safe area view a class name equal to bg white and an age of full. And then right within it, I will render our good old flat list. As the data, I'll simply pass the data. And as the render item, well, here we decide how we want to show that item. First, I want to destructure the item and the index of that item within our list. And I will open up a new function right here. Then within it, I will return a view that'll have a class name equal to flex1 and max W of 48%. I found that value to work the best. Don't forget to import the view from React Native. And within that view, render a piece of text that says menu card. Of course, make sure to properly close the flat list so you don't get this error. And now if you head over to the search, you can see 6 different menu cards because we have a limit of 6 right here. Now we can pass some additional properties to the flat list. So I'll put this data in a new line and the render item in a new line as well, and indent everything properly, and maybe collapse it just so we have a clean view. Additional properties that I'll pass is going to be a key extractor. Here, for React Native apps to work properly, you have to give each item a distinct ID, similar to what you have to do in React applications. So now I'll just rerun it, and we still have 6 items right here because it knows their distinct IDs. I'll also use a prop called num_columns and set it to 2. It is super cool that you can automatically just pass this magical prop to React Native, and it's gonna know to render it in 2 columns. But we get a warning saying that changing num_columns on the fly is not supported. You have to change the key prop on flat list when changing the number of columns and then force a fresh refresh. So if we do it now and head over to search, you can see that now they're shown in 2 different columns. We can also set the column wrapper class name to a gap of 7 to give it some more space. And we can also give it a content container class name to gap of 7 and a padding X of 5 with a padding bottom of 32 to create some additional spacing. And there's literally a prop for everything in React Native components. Like, it's super cool to be able to this easily change it. And now we can define the header. So list header component, that's a prop as well. So we can define it as a new callback function that will automatically return a view at the top. And this view will have a class name equal to margin Y of 5 and a gap of 5 too. And I'll stop saving it every time because as soon as I save it, I get redirected back to homepage. Next, we have a view within it that'll have a class name equal to flex between, flex row, and a W of full for full width. Within it, I'll have another view that'll have a class name of flex start. And then within it, I'll render a piece of text that says search. So now I can save it so you get the idea of what it is for. And I'll give it a class name of small, bold, uppercase, and text dash primary. So now we can see search at the top. And then just below this text, I will render another view that'll have a class name equal to flex start, flex row, a gap x of 1, and a margin top of 0.5. And within it, I will render another piece of text. And this one will say find your favorite food. And it'll have a class name equal to paragraph semi-bold, text dark 100. So if we save it, now you can see this title. And we can head below this text and below 2 more views. And then here you can render the cart button, which if you import it properly from the top, will make it appear right here on the right side. So now we can see the cart, which shares the same global state, both on the home page and on the search screen. Below this view that's wrapping the cart button, we can also render a piece of text that says search input. And then below it, we can render another piece of text that says filter, because we'll implement both the search input and the filter very, very soon. Finally, what happens if we don't have any elements shown right here? There has to be a way to provide just a loader or an empty state. Typically, you would have to do that using the if-else statements. But believe it or not, with React Native, there's a prop for that too. We can just call it list empty component, and we'll say if not loading, then we will render a piece of text that says no results. You could actually test this out if you made the function return an empty array, but for now we're good. Now, if you compare this to the final design, you'll notice that we have this cascading style where some elements are on top of the others, creating this organic look and feel. So let's actually implement this as well. If you head back, right at the top of our render item function, we can say const is first right call item. And you can basically check whether it's an even item. So we'll evenly divide it by 2 and check if the remainder is 0. If that is the case, then we can apply some special classes, such as wrapping this view with a CN, always providing it with this class name, but then only if it's not first right call item, give it a margin top of 10, else give it a margin top of 0, and properly close it at the end. If you do this and get back, you'll notice that now they're cascading. We have one on the left, then we have one a bit down. Here, like a waterfall. So now that we have this layout, we are ready to create the individual menu card element, so we can actually display it right here. So now let's create a reusable menu item card that we can then put here and replicate for all of the items. We can do that by creating a new component within the components folder, and I'll call it a menu card. .tsx, run rnfe, and then just put it right here. Perfect. Head back over to our search, and instead of rendering a simple piece of text, actually render the menu card that we just created, and to it, you can pass the entire item as a prop. So item as menu item, so it knows what it is. And this menu item will contain all of these important information about the menu card item. So let's head over into it and let's fetch those props and implement it. We can start by destructuring the item and then further destructuring the image URL, the name, and the price from it. And this will be of a type item is a menu item, so that our app knows what we're working with. Then the way you read images from storage in Appwrite is you have to form the URL out of your image URL and the Appwrite project ID. So I'll say image URL is equal to a template string of image underscore URL, and then question mark project is equal to, and then you can pass the Appwrite config dot project ID. So now that we have this image URL, we can actually create each one of these cards, but it won't be a view, rather it'll be a touchable opacity because you'll be able to click on it. Within this touchable opacity, we can render an image, and this image will have a source equal to URI is equal to image URL with a class name equal to size of 32, absolute, and minus stop minus 10 to make it feel like it's floating, with a resize mode of contain. So now if you save it, you should be able to see, if you head back over to your search, all of these different fast food items appearing on your screen. That's too many of them. And what we can also do is render a piece of text just below it. This text will render the name of the item, and we can style it a bit by giving it a class name of text-center, base-bold, text-dark 100, and a margin bottom of 2 to divide it a bit from the image, with a number of lines property set to 1, so it can actually not go into 2 lines. And this will of course make it look a tiny bit better for now. Below this text, we can also render another piece of text that will render from, and then $, and then the price. This one will have a class name equal to body regular, text-gray-200, and a margin bottom of 4. Below it, we can finally render a touchable opacity, so another button, with an empty onPress function for now. And within it, we can render a piece of text that'll say add to cart with a little plus icon, and a class name of paragraph-bold and text-primary. So if we save it, it'll look something like this. Now it'll have the add to cart button and it'll seem even messier. But finally, to fix it, we just have to give this touchable opacity a class name equal to menu card. If you do it like this, you'll see that now it's gonna appear within this card. And we also have to give it some additional styles to make it look better on Android by selecting the platform we're on, so the operating system. And if it is set to Android, in that case, we can also give it an object of elevation is set to 10 and a shadow color equal to, and we can give it some hexadecimal value of like 878787. Or if we're not on Android, we can just make it an empty style object. So now it's going to look good on mobile as well. And with that in mind, we have just developed this menu item card. Well, it's pretty cool because finally we can visualize all of these items. And thanks to the native abilities of the touchable opacity component, these actually seem clickable. So as you hover over them, scroll, and for the first time we have a very nice flat list. So you can see how it's very optimized for all of these different items. Sorry for scrolling too fast, but yeah, you get the idea. You can now visualize these elements. The photos, of course, make it so much more appealing because you can visually see what it is about. The price, of course, is very small and hidden, and you can just immediately add it to the cart. But before I actually implement add to cart functionalities, in the next lesson, we'll focus on this little search input and filter right here below the search at the top. I'm referring to this part right here. Of course, this is a typical search input. And then this is a slidable filters bar, which I think you've seen pretty much on every single mobile application. So let's do those next. Next up, let's implement the filter functionality. To do that, I'll create a new component right here in the components folder, and I'll call it filter.tsx and use RNFE to quickly spin it up. And we can do the same thing with the search bar. So right here in components, I'll create a new one and I'll call it search bar.tsx. I'll also run RNFE. And now we can just import both of these components within our search.tsx, where we before had just simple pieces of text. That is right here within the list header component. We have the search bar first, which we can import from component search bar. And then after it, we have the filter. So I'll also render a self-closing filter component here. Perfect. Make sure to import it from the right place, not this one right here. It's going to be coming from components. So I always like to utilize this WebStorm autofill that very quickly gets me the needed imports. I reloaded the screen because there was some weird error happening, but typically once there are no issues, but something shows up as an error, you just have to reload the screen and then we're back. So now let's dive right into the filter component and let's get it implemented. The way in which this filter functionality will work is when you click on a specific category type, its ID will be added to the URL as a search parameter. And on search screens, as soon as this URL search param value is changed, we're going to call the same Appwrite query to get all the menu items, but now with this category selected as a filter. We're not managing category in a local state, but rather we're managing it as a part of a URL state, similar to what we're doing in Next.js. So to make that happen, let's head over into our filter and let's destructure the categories that we're going to pass to our filter as a prop of a type categories will be an array of different categories coming from types. Perfect. Now immediately we can get access to the search params right here because as I said, we'll be modifying it through a URL. So I'll say use local search params coming from expo router, and I'll create a new use state snippet called active and set active so that we know which one is active at any point in time. And by default, I'll set it equal to search params dot category. So the one that is already selected, or I'll make it equal to an empty string like this. And don't forget to import use state coming from React. Perfect. Now we'll also need to have a handler function when we actually handle a press on a specific category, which will take the ID of a type string of that category. I'll implement this soon, but let's first craft the different filter data that we're going to pass into this selector. So filter data will be of a type category or a $ID of a type string and the name of a type string. And actually it'll be an array of those properties. So array of different categories, and it'll be equal to categories. If categories actually exist, then it's going to be an array where we're going to have an object with ID of all and the name of all as well. But we will also append all of the additional categories that might have been selected. Else, if we don't yet have any categories, we'll simply make it ID of all and name of all without adding those additional categories that we had right here at the top. So how do you think we're going to implement this filter component? Well, here's the kicker. It'll actually be a flat list component. Yep, that's right. So a flat list doesn't have to be just a vertical list like this one. It can also be a horizontal list of different things, like here. So I'll render a flat list so you can see its versatility, and I'll pass in the filter data that we want to render, and we want to define how we want to render a specific item. So let me actually put that in a new line so it's easier to see. We have the data, we have the render item, and we also need a key extractor so that we can differentiate different items. It'll look like this. So now, how will each one of these items look like? Well, first, I will destructure the item out of it, and for each one, we will automatically return a new touchable opacity because we want to make it clickable. We want to make it a button. Each one of these touchable opacities will just render a new piece of text, and that text will simply render the item name. So now if we save this, you should be able to see just a list that says all right here at the top. Not a real list, at least not right now. But what if we pass more categories to it? We're calling it right here, and it definitely wants us to pass that array of categories, which we are fetching from this hook, categories. So let me just pass categories equal to categories as a prop to the filter. It says that null is not an assignable type, but in this case, we know that we're going to return some, so I can just add an exclamation mark right here to let it know that we know that we're going to pass some props. Oh, and it looks like I actually forgot to return the categories from the getCategories function. So we simply have to add return categories dot documents. And now it's going to return them from this function. And now if we head back over into the filters, we should be getting them as props, and then we should be rendering them right here as part of that flat list. So now we can see burgers, pizzas, burritos. They don't look like filters yet. They look like a list. But trust me, we can make this list actually behave like a filter. So let's first style it a bit by rendering this flat list as horizontal. I'll also give it a prop of show horizontal scroll indicator of false, because people will know they need to scroll through it as it's going to go beyond the screen on the horizontal way. And I'll also give it a content container class name of gap x2 and a padding bottom of 3 to create some spacing. So now it's already starting to look a bit more like a filter list. But let's actually style each one of these buttons within it. We can do that by giving each touchable opacity a key of item.$ID and a class name equal to cn, to which we can always pass a filter class, but only if the active element is triple equal to the current item, so item.$ID. Then we can also give it a bg amber of 500, else we can give it a bg white. So this way we can differentiate the active or inactive elements. There we go. This is better. Then let's also give this touchable opacity another property. So I'll do it right below, and I'll call it style. So we can define a new style depending on the platform operating system. So say platform.os, and if it is equal to Android, in that case, I'll also give it elevation of 5, as well as a shadow color of like #878787. Else, I won't do anything on iPhone devices, so I'll just make it look like this. Finally, on press of this touchable opacity, we want to call the handle press function, and to it, I want to pass the ID of the item that we clicked on. So item.$ID. Finally, we can style the text a bit by giving it a class name equal to cn body-medium. And then if active is triple equal to item.id, then we'll give it a text white because it's going to be on a orange background. Else I'll make it text gray 200. So now if you save it, it looks like we don't have any currently selected items, but we will have them soon. So let's actually implement this handle press function so we can actually select some of these filters. To do that, we're accepting the ID, and I'm going to set active the ID that we clicked on. As soon as you do this and head back, already you can select an active item, which makes it so much more functional. But now we have to actually change the router settings in order for our filter to be reflected in our app. So let me check if ID is equal to all, like no filter, then we can simply use the router.setParams to set it to category of undefined. It doesn't exist. Or I think null should be okay as well. But else, I will set the router.setParams to a category and choose an ID of a category that we're passing into this handle press. So basically, you can now select any one of these different filters, like wraps, for example, or burgers or pizzas, and immediately see what item you can order. Or you can just head back over to all, which will cancel the selection and show you all the different items. This is perfect. It's working exactly as expected. So similarly, let's develop the search functionality using the same URL state management. I'll do that by heading over into our search bar component, and I'll start with the UI by giving this view a class name of search bar, and then it'll look something like this. And within it, we can render not a text, but a text input with a class name equal to flex1 and a padding of 5. And text inputs are self-closing components, so we can just remove the closing. And also give it a couple more props, such as a placeholder of search for pizzas, burgers, and more. And then we have to handle the value of the search. So I'll create a new use state snippet, and I'll call it query set query at the start equal to the query coming from params. So like before, I can try to get access to params and make it equal to use local search params, which will be of a type, an object with an optional query of a type string. So now, as the default state, I can set params.query, which if it exists, it'll autofill it. Perfect. So now we can set the value of this piece of text input to a query. And we also need to create a handler function. So I'll call it const handle search, which will be equal to a function that accepts a text of a type string. And then we can just add it right here. On change text, we'll call in the handle search function. And finally, we can also pass a placeholder text color of something like hash A0, A0, A0 and save it. So now it looks a bit more like an input and you can actually click on it. And below that text input, I will render a touchable opacity with a class name equal to padding right of 5, as well as on press. For now, we can just call a console log that'll say search pressed. Later on, we can do something else with it. And within this touchable opacity, I'll render an image that'll have a source of images.search. Make sure to import those images from constants. And then a class name of size of 6 with a resize mode of contain, as well as a tint color equal to something like hash 5D, 5F, 6D. I found that tint color to work well. And now if you save it, it should also get this icon on the right side. And the only thing you need to make it work is actually set the query right here in handle search by saying set query to be equal to this piece of text that the user is typing in. And then after that, you can set the router params by saying router.setParams of query to be equal to this new text. So now if you take your phone and search for something, like maybe let's go with one of the items here, like a pizza. Oh, and notice how the keyboard jumps out after every time I type something. We definitely want to fix that. So the search is working, but there's one important update that we need to make with every single search that we create. And that is a concept known as debouncing. See, if you type really fast, then for every single keystroke that you make, we'll make an API request to our database. And that is very overwhelming for the server and the database. It makes our app run slower. And let's be honest, a user doesn't need output back for every single keystroke. In most cases, they want to type the full word, right? So we have to make it so that while they're still typing, we don't make requests, but as soon as they stop typing, we immediately make it. So we can do that by introducing this concept of a debounce. There's a simple package that lets us implement it, and it's called use debounce hook. So in our second terminal, just run npmi use debounce, and then we can use it as a hook right at the top by creating a new variable const debounced search, which will be equal to use debounced callback, which you have to import from use debounce. And then to it, you can pass a callback function that accepts a text of a type string. And then instead of us setting the router manually, we'll call it only when we finish typing. Something like this. And then as the second parameter, you can provide after how many milliseconds will you actually make the request? How many milliseconds will you wait for the next keystroke? And we can say that the wait time is about 500 milliseconds, so half a second. So now, alongside setting the query to the state, we can also just call the debounced search and pass the text instead of just doing it for every single keystroke. So now, if you type in and you start typing, you can see that you can continue typing and no request will be made. But as soon as you stop, one request will be made. But it still looks like our keyboard gets closed as soon as we stop typing. So let me test it out one more time. If I search for something like pepperoni, it actually works out. But one issue that we have is as soon as you start typing or try to delete something, it actually doesn't fully delete it. And that's because setParams is triggering an update after each keystroke. But if we switch it over to router.push instead, and then just override the query by providing a /search query is equal to the text we're trying to update it to, well, this will not re-trigger for each keystroke. After you make this change, you can just reload your application, head over to search, and try something like pepperoni. Perfect, that works. But still, after every keystroke, the keyboard closes. We don't want that to happen. And it looks like I also got this warning right here at the bottom saying that text strings must be rendered within a text component. But let's fix this issue first. Now, I've done some research. Or in other words, I've done a ChatGPT search and a Google search. And apparently, the reason why the keyboard is still closing after a short pause is likely not our code, but a common issue in React Native, where if you put a text input inside of flat list's header, you will lose focus and the flat list will re-render. This causes the keyboard to automatically dismiss, even though you're not navigating or tapping anything. So here's one way in which we can fix it. Instead of using this debound search, which I will now completely remove, as we won't be submitting anything on key press. Rather, within this handle search, I will simply be setting the query, and then if the text is empty, so if there is no text, in that case, I'll also reset it within the URL by saying router.setParams of a query set to undefined. So that's one thing that we can make. But other than that, we'll also handle the submit. So I'll create a new function, const handle submit is equal to a callback function where we check if query.trim is not empty. So if is empty, so if a query doesn't exist, not query.trim, in that case, we'll set the router dot set params to be equal to the query we typed in. Oh, and here I actually wanted to check if query exists, then change it. So that's a mistake on my end. If query.trim exists, then set it to the query. And now we're passing the same query value to the text input and onChange handler. But what is different is that right below our onChange text, I will also add on submit editing. And here I'll call the handle submit. This will submit it when you press the enter key on the keyboard. And we can also set the return key type to be set to search. This will show search in the keyboard UI. And finally, we want to utilize this button that we have. So we can say router dot set params, and we can set them query equal to the query. So we actually modify it, but this time on the press of the search bar. So now if you start typing something like let's go for pepperoni, notice how at the bottom of my keyboard, right here at the bottom corner, there's a little magnifying glass. Can you see it? Right here. That's because I chose the return key type of search. So now the user knows that to be able to submit a search, they actually have to click that button and then the search will happen. Similarly, you can remove everything and it nicely gets removed. We can also search for a burrito. And that works like a charm. I'll continue searching for better solutions for handling our search bar. So if I actually do come up with something, I'll put it within the video kit down below and I'll name it something like improved search bar. So you can just copy it and override what you have right now. And then I'll also leave some comments so you can figure out exactly what I did to come up with an even better solution. Okay, but for now we get this warning saying that text strings must be rendered within a text component. Now this is pointing to this use local search params, so I'm not actually sure where we're rendering regular text. Oh, there's a letter R right here. Perfect. So whenever you have a piece of text, it has to be within a text element. But in this case, it was just a typo. So with that in mind, we now not only have amazing filters, which everybody's going to use even more often, but hey, if they want to go for something different, maybe like a bowl, then they can search for it and find it right here. Perfect. With that in mind, search and filtering has now been completed. So let's go ahead and actually commit it. I'll say git add dot git commit -m implement search and filter and git push. Perfect. And now that we've implemented this search page, it's a pretty good time to head back over to our Sentry's dashboard to see what we have here. Looks like Sentry has updated their look, so we can kind of try it out. Okay, I like that. It looks like they're not afraid to go with a bit of a wilder design with these cool shadows, and I actually like it. So you can see that as we were using the app, or some other users maybe, some new errors and events have accumulated. And actually, it looks like 3 or 4 different users encountered this error. So it would definitely make sense to rank it as a high priority error. It was first seen 2 days ago, but it's still present about 12 minutes ago. So it would be a good time to either assign it to somebody or resolve it ourselves. And let me show you what else we have besides just the issues. There's also user feedback, which allows your users to easily create bug reports so they can let you know about these sneaky issues right away. And every report will automatically include related replays, tags, and errors, making fixing those issues that simple. I thought these are only available on the web, and as you can see, I'm using Sentry on my course platform, and right at the bottom, there's this user reporting feature so that users can immediately let us know what went wrong. But it's super cool to see that it's available for native apps as well. Other than that, under Explore, there's a new logs feature, which is right now in beta. Logs allow you to send, view, and query logs sent from your applications within Sentry. So in simple words, you can send text-based information from your application to Sentry, and then you can view those alongside relevant errors. One of the requirements for setting logs up in React Native is to have a Sentry React Native SDK version of 7.0 beta. And right now, I am at 6.16. So depending on when you're watching this video, logs might already be out of beta, or if you want to immediately dive into using logs, you can just go ahead and update your Sentry React Native SDK version. Setting it up is super simple. It basically gives you access to the logger object, and then you can log different errors or info pieces, and you can also pass additional attributes directly to these logging functions, such as tracing, debugging, providing info, warnings, and more. And the point of it is that you'll be able to super easily track it within your Sentry dashboard. So all of the data will be centralized in one place. So for example, in our case, if adding an item to cart goes wrong, we can set that as a high severity error. And then as these logs start piling up, we can immediately know that something is wrong, and we can set Sentry up so that it lets us know immediately as soon as something goes wrong, so we can go ahead and fix it. Alongside logs, Sentry also allows for replays. You can basically see a video-like reproduction of your user's sessions, so you can see exactly what happened before, during, or after an error or a latency issue. And I like how they say latency issue right here, because oftentimes these are not caught. So being able to see a replay of how your user is using the app is super useful. Now, I could talk about Sentry's features for days. First of all, because there are so many and they're so detailed. And second of all, because I just like using them and we're actually using them on our own platform. But I think we covered a lot of ground on Sentry for a single video. I'll definitely use it again in the future, and I'll show you some other cool features that you can try out. Okay, now that we can search and explore different items that are available for us to order, let's actually implement the functionality to add them to the cart. So within the store folder, right next to the Auth store, I'll also create a second file called cart.store.ts. And for this one, I'll provide you with the code down below, and I'll explain how this entire file works. So you can find it within the video kit down below, and then let's go through it together. First, we import the cart customization and cart store types to keep our store strongly typed. Then we import create functionality from Zustand to be able to create a global state. Think of this like Redux, but simpler. And then I create a utility function called rCustomizations_equal to check if two customization arrays are identical by comparing their IDs. So A and B. And the way in which it works is we first check whether the length differs. We then immediately know that they're not equal. We then sort both of these arrays so we can reliably compare them one by one. And then we check if every corresponding item has the same ID. If that is the case, the customizations are equal. We're going to use this later on. Then we use Zestin's create hook to create a store called useCartStore. It returns our entire cart state and functions to update it. So we start with empty item, but then we have different functions like add item, remove item, increase quantity, decrease quantity, clear cart, get total items, get total price. So all of these different functions are attached to this global store. And all of this code is just plain JavaScript. We're dealing with adding and removing different items from it and just checking whether it was added before or not to make sure that we have a robust cart system. Because building a cart store requires a deep understanding of how users interact with e-commerce systems. The cart must be able to handle a variety of different actions like adding items, adjusting quantities, or even including optional customizations, all while maintaining accurate totals. So the goal is to answer the core question: what defines a unique cart item? And for a food delivery app, it is not just the menu item, because a cheeseburger with extra cheese or a cheeseburger with fries are two different things because they have different customizations. So we can't just track it by a menu ID. Rather, we need a combination of a menu ID plus customizations to identify an item uniquely. So at the center is an items array, right here, that contains all of our items. And here's a type of how each one of these cart item types look like. We have an ID, a name, a price, image URL, quantity, and then finally an array of different cart customizations. And they're optional because not all items need them. There's a plain Coke or margarita pizza that doesn't have any add-ons. So by making it optional, the cart works for both simple and complex options. And one of the most important steps is to identify unique items, and we do that using this rCustomizations utility function. As I said before, it basically combines two different arrays, sorts them, and then checks whether they're the same. So for example, it ensures that burger, fries, and Coke is not treated the same as burger, extra cheese, and fries, even if both reference the same menu item. Then of course, we were on the add item. And what we do here is we first check whether an item with the same ID and same customizations already exists in the cart. So if it does, then we just increase the quantity, else we add it in the cart in the first place. Then there are the increase and decrease quantity. Once again, we do a very similar thing. We check whether the customizations of that item are the same. And then if they are, we increase the quantity by 1. And for a decrease, we decrease the quantity by 1 as well. Also for this one, if the quantity is lower than 0, we then just remove it from the array. This logic will ensure that you're not just blindly modifying the wrong variant of the item. And similar for other functions like remove item, clear cart, get total items, all of them are serving a very important part of making sure that the cart logic works. But now that we have this cart logic, let's actually get it implemented within a new screen that we want to create, and that is a cart screen. That screen will look something like this, where we can choose a location, and then we list out all of these different items alongside the payment summary at the bottom. So this one will have a very simple header, something similar to what we had on the homepage. So let me just give you the code for that. Since it's super similar to what we've already done, you can just create a new component within the components folder and call it custom header.tsx, and then just find the custom header within the video kit down below and paste it right here. As you can see, it is just a simple button, some title, and then an icon. And now we can put this component to use within the cart screen. So let's go ahead and head over into App, Tabs, and then Cart. And we can just wrap everything in a safe area view with a class name equal to bg_white and h-full. And within it, I'll just render a flat list. Yep, we are rendering yet another flat list so you can see just how common they are. Then we can utilize the cart store that we have created by saying const and then destructuring the items, the get total items, as well as the get total price. And these are equal to the use cart store that we created. And then we can even call the total items and assign them to a variable by saying total items is equal to get total items. And in the same way, total price will be equal to get total price. So now that we have those items that we want to render, we can just render them as data, which is a prop within this flat list. So I will simply say data is equal to items. Then we can choose how we want to render a specific item. For now, it'll just be a callback function where we destructure each item and automatically return a text of cart item, for now static. And then we can finally close this flat list right here. And we can also give it a key extractor equal to item.id. We can then give it a content container class name equal to padding bottom of 28, padding x of 5, and padding top of 5 as well. And then a list header component, which now will be equal to a callback function where we just return this custom header component to which we can pass a title of your cart. So now if you head over to the cart, you can see the your cart at the top with a little search on the right and the back arrow on the left. Also, in case the cart is empty, there's even a prop for that, list empty component. We will just provide a callback function and we will return a piece of text that says cart empty. And then finally, we have what's going to take the most space right here, and that'll be a list footer component, which will check if total items is greater than 0. And if that is the case, it'll return a view with a class name equal to a gap of 5, and within it, another view that'll have a class name equal to margin top of 6, border dash gray dash 200, padding of 5, and the rounded dash 2XL. And within this view, we can render another piece of text that'll have a class name equal to H3, bold, text dash dark 100, and a margin bottom of 5. And then within it, we can just say payment summary. So now if you save it and head back to the cart, you can see cart empty right now because we're not passing any items to it just yet. And we can also render some information about the price items. So if you head back over to the design, you can see that we have these 3 or 4 similar lines. Text on the left, and then the price. Text, price, text, price, text, price. So let's actually turn this into a new reusable component. And since we'll only be using it in this page, we can actually create it above. We can call it payment info stripe. And what this is just a component that will automatically return a couple of views and some text. Since we've created many of these before, I'll just provide it within the video kit down below, and then you can copy it and paste it here. I will also make sure to indent it properly. There we go. And you can just pause and copy it as well, or just get it from the video kit down below. And make sure to import CN from CLSX. Now we can use this payment info stripe to show all of these different payment information, such as below this piece of text, we can render a payment info stripe and render a label of something like total items. And then we can render in parentheses total items. How many items do we have? And then we can also give it a value, but let me first put it into multiple lines so it's a bit easier to see what we're working with. There we go. Then we can also pass a value of $, total price dot to fixed to. Typically when you're working with currencies, you want to fix it to 2 fraction digits. So now if you head over here, the cart is still empty, but very soon as we add the ability to add different items of the cart, this one will show the total number of items. And we can duplicate it below just a few times. 1 and 2 should be fine for now. The second one will render the label of delivery fee. And for now, we can just hard code this to something like $5. So I'll just say $5. For the next one, we can maybe provide some kind of a discount. So I'll say discount. And this one, we can also maybe hard code to something like minus $50. And we can also enter an additional value style of exclamation mark text dash success. So it's going to make it appear in green. Then just below it, I'll render another view, which will act just as a line. So we differentiate it from the final total that we have, which will have a class name equal to border-t, border-gray-300, and a margin y of 2 to create some space on top and bottom, which is going to make it look like this. This is the line that I'm talking about. And then finally, below it, I will render one final payment info stripe. So let me just copy it here and paste it just below. Here, we can just say total. Then the value will be total price dot to fixed. And then you also need to include the other numbers, +5 minus 0.5. All of that together can be wrapped in the to fixed, not just the total price. So I'll put it all in parentheses. Total price +5 minus 0.5 dot to fixed 2. And now we're showing the total price. Of course, later on, you can make this dynamic. Let me also render the label style of base-bold and text-dark 100, as well as a value style, which I'll set to base-bold, text-dark 100, as well as text-right to move it to the right side. And finally, right below this view, I'll render a custom button that will have a title equal to order now. Perfect. So now, back in the cart, as soon as we fill something in, you should be able to see all of these different pieces of info. So now, before I add the UI of these individual items that we can add to cart, let's implement the add to cart functionality. We can do that if you head over to our menu card component, which we already created, and to it, we're passing some props, such as the entire item. Now, one additional prop that we can pass to it from the item is the $ID of the item we want to add. And with that in our pocket, we can very easily get access to the add item functionality coming from the use cart store, and then we can just call it. Right here on press, when we press this touchable opacity, we can call the add item, and to it, we need to pass a couple of props, such as an object with an ID pointing to the $ID. Then we have the name, the price, the image underscore URL, which we have to specify to the image URL, which is in camel case, and then finally an empty customizations array. Perfect. So now we have a button that will allow us to add a specific item to the cart. And just before we actually go ahead and test it out, let's also head over to our cart button. Remember that one that we created at the start, where right now the number of total items is hard-coded? Well, instead of hard-coding it, we can now actually fetch the real number of total items by saying const destructure the get total items, and that's going to be equal to the use cart store. And then we can just say total items is equal to get total items. So now if you head back over to search or the home, you should be able to see that it doesn't have any kind of a number or a badge on this icon right here. But now if you tried adding a classic cheeseburger to the list, you can see that now that cart shines with the number 1. And then if you head back over to the cart, you'll see that now you just cost yourself $30 for a classic cheeseburger. That's a lot. But hey, let's at least visualize it so we can see what we're paying for. Because right now, it's not super clear. So head back over into the cart. And then right here for now, we're simply rendering a text that says cart item. But we want to see it. We want to know what we bought. So for that reason, let's develop a new component within the components folder. And let's call it a cart item.jsx and run rnfe right within it. And then we can head back over into the cart and just import it right here. So instead of passing a simple piece of text, we can actually render a cart item. And then to it, as props, we can pass the item itself equal to the item that we're currently rendering. Now, as before, this actual cart item is just a collection of different views, images, and text elements. So I'll drop the full cart item right within the video kit down below. Oh, and it looks like I called a file JSX. It was supposed to be TSX. So I'll just rename it to TSX right here. There we go. And now if you add this cheeseburger to the cart and head over here, you can see it. You can also increase or decrease the quantity and it'll automatically be reflected within the payment summary. And that's all being done by the Use Cart store, which manages the store of the price and the items within the cart globally. And if you want to, you can also try to order some food for your friends, maybe a spicy chicken sandwich or a margarita. And now you can see that it says 3 items at the top, right? You can also head over to that cart item component, or rather the cart button, I think we called it. And on press, we can actually push it to the cart component. So I'll say router.push to /cart. So now I don't have to use the mobile nav. I can just click at the top here to see what I order. And you can see all of these items right here within our cart. The changes are reflected immediately. You can add additional items or you can even remove entire cart items, and the changes are reflected immediately. Great job on implementing the cart. Congrats, you've made it all the way here, and that's amazing. We covered a lot of ground, everything from setting up a React Native project to configuring routes and different types of navigation, building Auth Screens from scratch, implementing state management with Zustand, and architecting a scalable database using Appwrite, making sure that we don't have any errors using Sentry, and so much more. Now is your turn. We've implemented this cart UI and cart frontend functionality, but you can very easily extend this further to use real Stripe payments and implement payment processing. And if you don't know how to do that, you can check out this other video that I've posted called Build a Full Stack React Native App with Payments. And if you take a look at some of these chapters here, you'll see a whole section just on Stripe payment integration. So you can watch that section and implement it for this app too. Alongside the payments, I've also left out a couple of screens so you can test out everything you've learned so far. You can try to implement this very visually interesting menu item details page where you can see more info about each one of these items, such as a type, rating, price, calories, protein, bun type, and more. And you can even implement this functionality for adding different toppings. And another challenge to test everything you've learned so far is for you to recreate this profile screen by closely following the Figma design. Don't worry, it's not hard. Just start with the basics. Begin by building the UI layout, then fetch the user's data from Appwrite and render it on the screen. And you already know how to get the user info, right? Remember the Zustand Auth store we built earlier? It's all there, ready to use. And as a bonus, you can also try implementing this logout feature, which you can see in almost every single React Native application. If you want a hint, well, it only takes 1 line of code, and you can easily find it within Appwrite's documentation. Once you're done, you can check your work against the final version of this project in the GitHub repository, where this profile page has been implemented. So, with that in mind, I want to thank you for taking the time and coming to the end of this amazing build. Take the phone in your hand and just try to move through some of these pages to see what you've developed. It is all looking great, and now that we have these filters right here, another great thing for you to do would be to make these initial cards clickable So once you actually click on burritos, pizzas, burgers, or summer combos, you just re-navigate over to the search screen with a specific filter pre-enabled. Hopefully that makes sense, right? This is not just static images. The goal is to make this dynamic and then navigate over to the second screen. I really wanted to give you some additional exercises for you to actually try to implement some of these things on your own. The goal is not just to watch, the goal is to understand and rebuild it on your own. And that's exactly what we do on jsmastery.com. If you haven't yet checked it out, well, now would be a time to do so, because very soon, alongside the Ultimate Next.js 15 course and a GCEP course in which you rebuild the entire GTA 6's landing page with some of the craziest animations I've seen. And very, very soon, we're dropping the Ultimate React Native course, where we're gonna dive so much deeper into how React Native works behind the scenes so that you truly understand how all of its components work and how its engine is actually powering those mobile applications. Oh, and we'll also go through deploying and hosting your applications on an actual app store. So, if you haven't already, either become a member right now or join the waitlist for the React Native course that's coming soon. With that said, thank you so much for watching, and I'll see you in the next one. Have a wonderful day.